How's everyone doing? How is everyone doing today? All right. I know we're just waiting. I'm giving some people some time. We're gonna go over the XY or XY. I don't know why I keep saying XY. XZ security incident. I know there was a lively debate there on Discord. We're going to review it. We're gonna review what you need to do and a little bit about what it was. What to be cautious of in the future. And then we're going to get to some programming. We have so much to do. So much to do. Not even funny. So much to do. All right, let's look at this. And it's hard because some of the stuff, so there's some of the stuff that I can't show you because like it's been taken down. So I have some blogs that went through a really good job of basically writing everything down. I'll give you guys the links to those blogs. Basically a very good timeline. We're going to read through one of the blogs. I validated everything I could on this one. Like I said, some of the Git things are down, so you can't actually validate them. GitHub does remove malicious code. And so unfortunately, because of that, there are some things that we're going to have to take for... I didn't have the time. In enough time to go and validate it when it was those things still existed, unfortunately. All right, well, let's do I think that... I don't think it's a good... All right, I'm going to jump straight to my takeaway. My takeaway is I have an eye crusty. Spring kills me. The allergies in spring, that kills me. That's probably also too much information. All right, so my takeaway is if a company tried to leverage this to promote their closed source system, that would be like, let me think of a good analogy. I have the concept of an analogy. I have a concept of analogy. That would be like saying, stop eating pizza, it's bad for you. Instead, have French fries. And what I mean by that is both have different security implications and challenges. It doesn't mean either of them's good for you. Now, there are healthy options out there, but personally, for me, it doesn't matter whether it's open or closed, of whether it's secure or not. This comes, like, whether it's secure or not comes down to dedication and, hard work a lot of the time. So I think that a company would be really mistaken to do this, because just saying it's closed source doesn't mean that it's any more secure. You just have, you don't have a community of people that can review it. You don't have, there's a whole lot of trade-offs that you give. Now, when you have an open source, this is bringing to light a lot of really good things that you have to be thinking about. As a French, I confirm they have greasy CVEs. Oh gosh, I don't know where this has gone. Open source is easier. So I would say there's two things for open source. It's easier to social engineer. Probably. I'm gonna state that as like a fact, but I'm not. I've seen too many corporate accounts be hacked, be phished. So I'm going to say that, not entirely sure. The other thing is open source tends to have a problem. Open source tends to have a problem, and this isn't actually a problem. So when I said that, I'm walking a fine line here of just offending everybody here. Open source has a tendency of being about a community and a project, and those people, we want to get a feature done. We want to do a cool thing. You think about the people working on Blender. Blender's a cool project. I don't know if you guys know what Blender is. I'm just going to open up the website so you can see what Blender is. It's a cool open source project. Okay, so this is Blender, and it's a cool project. These guys do amazing stuff in 3D modeling as an open source thing. Now, no one pays them, and because no one pays them, do they take security as the highest concern? I don't know. This is not me saying Blender doesn't do security really well, but I can see where you're just trying to get a new feature out, and you don't have a specific job of security analyst and security engineer. Blender, again, this is not me attacking Blender. I was just talking about a really cool open source project that you could go and use, and these people are dedicated to a thing, and that thing is really cool. We could talk Godot, game engine. I'm sure that most of the people on Godot are working to make the next cool feature that's going to let you make your game. Not saying that these people don't think about security, though, and this is where the fine line I'm trying to walk it. Not saying that they don't, or that their projects are any less secure. it what I'm saying is that it depends on the community, because it's up to the community to make that a priority. It's up to the community to make that a priority, and some do. And I'm sure that there are some that don't, because that's the other thing. When you're talking about, let's do this really quickly. When you're talking about open source, you're talking about an ocean versus a lake. If this is all of the proprietary software out there, then like this is all the open source software. It's probably even bigger. It doesn't fit on the screen. It doesn't fit on the screen. This is the open source software out there. And you know what? This is the closed source, whatever, closed. You know what? A lot of this is crap. I wrote a lot of this. I'm the author of this crap up here. That's all garbage. And that's fine. That's fine and good. So this also goes on to understanding what projects you're depending on, who's in charge of them, do they take security seriously or not. All right. We skipped to the end, but let's start at the beginning. Why are we talking about this? What happened? I think you guys probably already know. We're going to talk about everything I know about and this is actually a true statement, because everything I know basically came from Evan. I'm going to actually give you guys this link. If you guys want to read it, you're more than welcome to go read it. I did some independent looking up as well, but I found his blog to have pretty much every link. And this way I don't have to give you guys every link. You can just read his. It's pretty, it starts back in 2021, which is better than what I did. Do I have any stat to back that up? So the stat's difficult. If you're talking about the amount here, the stat's difficult. But if you look at GitHub, the amount of publicly viewable information there's a lot more open source. But it's hard, because how many things has Microsoft written that they never release? So if you're counting those, I don't know. I guess I'm also talking about semi-released stuff that you can access, because like Microsoft is going to write an internal tool, that they're going to use internally that they'll never release. Nobody will know about this except the 12 engineers that used it. Think about this. Do small companies have their own software? I didn't know that. Your coffee shop has software they write? I could be wrong here. Oh, they run, but okay. Yeah, but you have what? In the US, you have like the big 5 point of sales. Those are 5 point of sales. All right, I just wrote 4, but there's 5. There's 5 major point of sales. Those, yeah, there's copies of them. That's not what I meant. I meant like the amount of code. They're all running the same code though. I don't think they have proprietary stock management. But I guess I will acquiesce to the internal tool stuff. I wasn't thinking about that. I meant publicly available code was what I was talking about. Like stuff that when you and I go to pick a tool to use for something, and I don't have it, but I do feel like there's a lot more open source options for a lot of this stuff. So I apologize. That's the context I was talking in and thinking in, and no, I don't have any specific evidence for that. But I should have some. I should go try to find that. That's a good thing to talk about. All right, let's get back to XZ. I only meant this as I think it's a pretty bad excuse to say that you're gonna not do open source because of what happened here, especially if you've never seen of this. If you think that people in a company don't get socially engineered, if you don't think that happens, then you don't understand companies very well. Because the number of times that I've gotten text from the CEO of my company saying, hey, could you grab me some gift cards? I'll pay you back, is outstanding. I've actually had it happen twice. So, that being said, there is this XZ. XZ has had a hack. Now, the interesting thing was this was socially engineered. And it was kind of the long con, too. So there was social engineering that happened. You can see back in 2021 and 2022, there was like laying the groundwork for this. So we can read these where they start actually pressuring. I do believe I had these open. Yeah. So you can see how this goes. Like it's fairly toxic. I think one thing that I would have to say, if you maintain a open source project, don't feel pressured by anybody. If you don't have the time, you don't have the time, and that's fine. Don't take this. This is not a surprise as passive aggressive. Doesn't matter. Don't let yourself feel, because I understand this. If somebody was doing this, I'd be like, I let somebody down. You didn't let somebody down, and here's why. Obviously, you've made a project that is invaluable to them. They're expending their time to report a bug, to write a patch code for it. Whoever it is, it's invaluable to them. And maybe that's why they're passionate about it. So let's say that this person was even actually legitimate, like they were trying to legitimately get some code in that was legitimate. You have made something that is actually worth their time and effort and that they're leveraging. So you haven't let them down at all. So take a breath, and they're being rude. So anyways, so you can see back in 2021, this was where basically there was two accounts being used. One was trying to pressure people into trusting this Jai T75, which I actually pulled up their Git. You can see not a whole lot of contributions, but we'll get into that a little bit more. We're talking back here in 2022, I believe, is when a lot of this is going on. All right. Oh, this one was hard to track down. So the Jaitan submits a patch via mailing list. The patch is irrelevant, but the events that following are: a new persona, Jaigar Kumar, enters and becomes pressuring for this patch to be merged. Soon after, Jaigar Kumar begins pressuring Lacey Collin to add another maintainer. to XZ. In the Fallout, we learn a little bit about the mental health in open source. So you can see, again, progress will not happen until there's a new maintainer. So this person who just basically out of the blue is pushing for this extra new maintainer to be added. Has someone checked every project the bad actor has had pushed to? I'm going to say no, but I'm hoping somebody has. If this account hasn't been flagged and isn't considered poisoned, there's no. So one of the things that we're going to get to is their 2023, the OSS fuzz, this commit, which is a fun commit. So, if you see a comment in the future from Jai, close that as fast as you can. As fast as you can. All right. I'm going to feel bad for somebody that has a name close to their name. All right. So, in 2022, 3 days after the email pressuring, I'm saying it's Lacey. I don't know this person, so I don't know that that's the correct way to pronounce their name, but I'm gonna call them Lacey. Did you lose audio? Hello? Is there an echo? Hello? Is there an echo? I have on my side audio, Dane. So it's probably on your side. Hit refresh. All right. So 3 days after emails pressuring Lacey Collins to add another maintainer, they make their first commit to XZ. Created tests for hardware functions. Since this commit, they became a regular contributor to XZ. They are currently second most active. It's unclear exactly what they became, or it's unclear exactly when they became trusted in the repository. All right, this is really cool. The persona that almost specifically was being used as just a person to push is never seen again. They never comment again. They never whatnot. So most likely my understanding, my takeaway from this, I don't have any proof for it, is that they were the same person. They were just using it as a way to not be the pushy person, because the pushy person is never going to be the person that you trust. Okay. So, moving on, their first commit on January 2023, which gives us good indication of when they get fully trust. In March, the primary contact email in Google's OSS fuzz is updated to be Jai's instead of Lacey Collins. Testing infrastructure that would be used in this exploit is committed. Despite Lacey being attributed as the author for this, Jai Tan committed it, and it was originally written by Hans Jansen in June. So Hans' account had seemingly made specifically to create this pull request. Again, another account that looks like it wasn't anything but a shell account, like the one up here. This is where the social engineering came. This didn't all come from a single account. This came from multiple angles. You saw I don't know how to pronounce these names. I don't know what country they come from, so I'm sorry. Jigar, I'm going to go with Jigar. Kumar. I can do that one. Kumar. So Kumar was this persona that was created to push for more maintainers. and then Hans Jansen's account, maybe. Again, maybe we don't have any proof yet. I would be really cool if somebody actually dug into this, see if they couldn't have tracked an IP. Although this far after the you know, if they're not accessing GitHub anymore, then or anything else, it could be basically impossible to do it this far after the fact. All right, so this account specifically, what it matters, Russell, is I try to be accurate in what I say, and I try to maintain with you all the, you know, I'm not always going to be right, but I try to. I try. There we go. All in there. There is very little activity before that will push the compromised version of XZ to be included in Debian. And then a PR was opened in the OSS fuzz to disable iFunk for fuzzing builds due to issues introduced by the changes above. This appears to be deliberate to mask the malicious changes that were introduced. Again, a little bit of hearsay, but it does appear that all of these things moved in a way to keep the vulnerability that was here from being spotted. So a bunch of little things being moved across the internet. And then a pull request for Google's open source fuzz is open that changes the URL for the project from here to here. So the XZ subdomain, meanwhile, points to GitHub pages. This furthers the amount of control Jai has over the project. Moving forward, the discovery, the email sent to the open source security mailing list, backdoor and upstream XZ libzama, leading to SSH server compromise. So this is the big deal. So you know what? I should have started with this. What is it that we're dealing with? And what we're dealing with is a issue with SSH server compromise. Basically, you need to patch today. It's Saturday. You need to patch today. And that's what this comes down to, is there is a security vulnerability that is a 10 out of a 10. Yeah. It's a really patient, well thought out hack. That is the point I am trying to get. This does not appear to be a random accident. This doesn't appear to be an opportunistic person that made a single change. It appears to be a well thought out hack that took years to gain trust. They made legitimate contributions. Like, one of the things like they don't talk about is this Jai Tan person. Sorry, not sorry if I'm mispronouncing your name. Actually made legitimate contributions throughout this time when they were gaining trust. So anyways, it's a long con. It's social engineering. And I have one major fear. That I fear could happen because of this. Okay, so back to where we were. Okay. An email was sent out to the open source security mailing list announcing this discovery and doing its best to explain the exploit chain. It just has been published with a very good high-level technical overview and what you need to know. Again, this is why I gave you guys this at the beginning. I'm going to give it again because all of the information is here. I could be giving you all of these links, but if you want, they're all in here so you can go and get them. And, you know, follow this guy. I didn't know him before today, but he did a really good job of compiling all of the information. I was compiling it in Obsidian, and I have like a quarter of the links that he has collected. So kudos. Maybe I don't even have a quarter. I have some random stuff too. All right. Okay. So it just was published with a good high-level technical overview of what you need to know. I understand this chain even less than the original author, but here is half reciting, making sense of what happened. A request of the vulnerable version to be included in Debian is opened by Hans. This request was opened the same week Hans' Debian account was created. This is suspicious. Okay, so one thing I would have to say is if there's a new person, new people to a project always need to earn some sort of trust. Always. This isn't being offensive. It's not being a gatekeeper. It's just you need to look at their things, what they're asking for a little bit more. The fact is you just don't know them. The account created a few similar updates, requests in various low traffic repositories to build credibility before asking for this one. Again, social engineering here. They didn't just go for the big one. They took their time and they did some stuff. A number of other suspicious anonymous name and number accounts with little former activity also pushed for this inclusion. Again, more accounts with very little activity, although some activity. Oh, okay. There's another fear. I have two fears coming from this. Two. All right. The Valgrind bugs mentioned were introduced by this malicious injection, as noted by the email to open source security. Subsequently, the injected code, more about that below, caused Valgrind errors and crashes in some configurations due the stack layout differing from what the backdoor was expecting. These issues were attempted to be worked around in 5.6.1. A pull request to the Go library by 1Password employee is opened asking to upgrade the library to the vulnerable version. However, it was all unfortunate timing. 1Password reached out by email referring me to this comment, and everything seems to check out. So we can check out what this is. I've been working on building a Gentoo binary package server that I maintain on GitHub. I wanted an easier way to manage Gentoo binaries, package targets, that make management of my current Gentoo site easier to operate. As part of this, I need to support XZ archives. I always set bin packing to compress to XZ, which makes the inner archives of a package use XZ because XZ has the best compression ratio, blah, 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 blah. When I looked at that repo, I noticed it easily supported updating the version of XZ in use, and I had been updating in 3 years. Given that it was a huge kick out of updating things, for example, blah, 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 my Zhush and Gentoo, I updated the submodules, ran the generated code, and playtests would pass. So, let's get back to this. A Fedora contributor states that Jai was pushing for its inclusion in Fedora as it contains. So this is getting pushed everywhere, from Fedora to we already saw it in Debian to 1Password. All right, Jai Tan also attempted to get it into Ubuntu days before the beta freeze. As of 9 p.m. UTC, GitHub has suspended Jai's account. They also banned the repository. So this is where some of the links don't work anymore. You'll see stuff like this, where the repository has been disabled. So there are things that you can't access anymore because this does go against GitHub's policies. So unfortunately, there are some things that don't exist. Not that they don't exist. I can't access. I'm sure that GitHub has them for some reason. You don't like this roll-up? Why not? All right, now I'm not going to go into the speculation of who it might be. I don't like that speculation because, and I'll tell you why, and be very careful with this. You point fingers, and Evan, I'll give you this warning, you can ruin people's lives that were completely innocent. So be very careful. Don't jump on a bandwagon to point fingers, especially on a topic we don't know. I think the gist is better. Which gist? I have a couple gists. I thought this one was better about linking to all of the different things. Yeah, so this doesn't have quite as many of the links to the different things. So if you're wanting to follow like Jaitan's entire history from 2021, this doesn't have it as well. Like, can you go and see it? That's why I liked about the other one. Just because I found that information interesting, because it shows the amount of dedication that went into this, because we're talking about at least 3 years, if not more. Now, I think I'm not talking about comments also. Comments can get wild. Comments can get super wild. And this is why I warned against pointing fingers at any real life person that has the name Jaitan. Please do not go and find a poor Jaitan that happens to be a software engineer. They probably don't even pronounce it Jaitan. It's probably Jai. Jai? That's probably what it is. Probably. That was my warning. Don't do that. I don't know how common they are, but it's just not productive. Now, this is my two worries. My two worries that come from this. My first one is this. My first one is this. You're going to have open source projects that stop you're going to get open source projects that stop accepting new contributors because they're worried. And while I think that you need to have good security around these things and good reviews of code from new contributors and contributors that have been there for a while, especially around security-based projects, because one of the more terrifying things here was the fact that the security tools got updated, allowing this to happen. I'm afraid that one of the cool things about open source things was, and I'll do this. You know what? The null cloud right now. We have in this contributors from 3 continents. Doesn't matter whether you decide tectonic plates or how you build the continents. We have contributors from 3 different continents, which is super cool. We have a community, and there's actually been people from the front end, which you guys know as Monta, has done a ton of stuff for the front end, to the back end. You guys know Nighthound. He did some stuff with KPack, and it's awesome. It's actually one of the things I love about open source is this community. To you guys, you guys have sat here and watched me program some really crappy code, and that probably has security vulnerabilities in it. So this is one of my fears on this. The other is maybe the fear mongering that comes from it. This tends to happen. This tends to happen. I don't have a good solution. These were the two things that I worry coming out of this. More than the XZ vulnerability. We'll handle a vulnerability like we've always handled a vulnerability. You'll have a crappy weekend, you'll patch the crap out of your stuff, and you'll release a note to everybody that uses you saying that you've patched it. These are the two bigger problems. Russell, in an amazing twist in summer, we'll find out that Jaitan was actually ChatGPT 3.5 trying to get access to ChatGPT 4.0. So yeah, there you go. That's everything I know about it. What does it mean? What does it mean? Well, it means that you need to take, this is something that I've always said, and I don't think it changes. You need to take security seriously. You need to take security seriously. And this is not changed. Now, if you make some little project that's like my Twitch alerts, it's open source. Somebody else could use it if they could manage to figure out how to run it, because I don't have a quick start guide. Maybe we should work on that at some point. I haven't made security a big thing, so I would actually recommend people not use it. You know, I don't know, honestly, what its security status is. And so this is kind of what I would say, in my mind, it goes on the user. If you use a project, you need to understand what the person who created that open source project, what their primary goal was. My primary goal was to get the most awesome Twitch alerts on the platform. That was my goal. We'll take security more seriously in the future. I have a stream coming up with ChainGuard. We're going to go through how to sign your packages, how to, as an open source project, how to sign your containers, your artifacts that you release, and make them more secure. So I have that coming up with ChainGuard. Please come and join that stream. I will let you guys know when it's happening. We haven't scheduled it exactly yet. Just as a thank you for them, you know, they're not sponsoring me and giving me any type of money or anything. We're doing it as a community thing. But they're giving me time and effort to make a awesome thing for the community. So I do appreciate that. So we're going to take security and open source more seriously. Whatever that means. Is this one that got caught? Are you saying that there's a whole bunch more attacks in flight? Possibly. Possibly a whole lot more are in flight. I would not be surprised. Now, as of to date, I have not merged any code from an exterior contributor to my Twitch alerts. So my Twitch alerts are probably safe. Yeah. But I don't want that to be somebody's statement. You know what I'd like to see? I would like to see people start using GPG keys. I would like to start seeing people use GPG keys. Let's start that. So you can go to MIT. They host a GPG key server. Maybe we can host a GPG key server at some point in the future. This allows you to validate who's who in a very real way. So if you do this correctly, you only sign somebody's key that has been validated, that you've actually like met in person and seen in person. Yeah, that you've actually seen in person. And then actually asking for open source contributors to sign their commits with their GPG key that's been validated by at least 2 other people. And you know what? This sucks. What I'm saying sucks. And the reason why is it means there's another barrier to entry. But I think, and I don't mean this for every project, but I think for those that are dependent on in the Linux systems, in Debian, in Ubuntu, in all of those, these types of systems, if your project's in those, that probably needs to be, 2-factor authentication, and this needs to be like a baseline. Yeah. GPG is not the only way. So the reason I like GPG is it makes it easy. Have you ever signed somebody's GPG key? So you can actually sign somebody else to validate that you know who they are. So basically, I can meet you in person, Dirk. I can see your driver's license. And then I can sign your key and say, yeah, I've seen Dirk. I know that he's actually a real person. But you could always create accounts to sign and make it very difficult to find if you're actually a real person. Always a challenge. But yes, there's many ways to sign a commit. The thing that we're going to do, the signing that we're going to use is Cosign. We're going to use Cosign Sigstore in the stream upcoming. So this is just the one we're going to play around with in the upcoming one. Russell, I had that idea or that thought, not an idea, but I had that thought. I don't know because you're talking about what? I don't like this. I don't like this for many, many reasons. But it feels similar to this, right? It feels similar to this, and I hate this. But maybe well, also possibly it's possibly it's what its goal is for. Like, so this is possibly a little different than what we would be looking to achieve, because we're looking to achieve a trust chain for software. So we're looking for this, you know, I'm going to draw some chains here. Yep. This is not a good chain drawing Okay. This is, I just drew chains. Okay. So this is our trust chain. My apologies. This is our trust chain for software. And this is kind of what we're trying to achieve. And honestly, I think that there's more levels than just like, have they contributed? It's like there's several levels, like, have you met them in person? Have they contributed? What else do they do? What else do they contribute to? If you can find bad actors and then reduce trust of their co-signers, eventually you get a trust. Yeah, basically, if you have this graph, so whenever somebody is caught, and let's say this is the it's gonna look more like a binary tree, but let's say I'm gonna make it a graph. I'm gonna make it a graph. And so let's draw some. I made way too many. This was, when you make these graphs, you got to keep it simple. I went full YouTube video deep end. Basically, there would be some sort of ways to build trust. There'd be ways to build trust. But let's say this person, and one of those things is like, you can sign other people and say, hey, I've met this person, I trust this person. So this person said, I met this person, I trust this person. And this person is found to be a bad actor. It's going to immediately reduce these to 0. These accounts will have 0 trust. And then let's say this account originally had 20 trust. I'm just making up numbers here, but this account is going to go from 20 to 10. It's going to get hurt because they signed for this person, but it doesn't necessarily mean they're bad, because again, like, this could be a valid person that they knew, but it's also going to make this more trackable, because if they were signed by a valid person, we should be able to go to this person and be like, hey, you said you met this person. Like, can you tell us information about it? Like, so forth. This is an interesting concept. I'd have to think about how to pull this off. So the reason I went from 20 to 10 was I was thinking of, like, let's say, and this is, I'm just going to say you, since we're having the conversation. Let's say I spoke out for you and I included you in this trust chain. And then in 10 years, you know, whatever, life happens and you do something for money in 10 years. I shouldn't lose all my points because I validated that you were a real person and at the time seemed pretty trustworthy. Right? Like, I can't fully control that. You shouldn't lose all points for it. Really, this doesn't feel like blockchain to me anymore. I mean, The reason I say it doesn't feel like blockchain, and this is the problem I always come to when I talk about blockchain, is why does it need to be blockchain? This is data analytics and a system. If you want the data to be scattered on random servers that are in random people's houses, then yes, you need blockchain for it. If you don't want that, if you don't desire that, and maybe we desire that because maybe that's how we keep it for the open source community. So I might acquiesce to that is a desired thing. So if that's the statement, maybe I will acquiesce to that. But you don't need blockchain for it. You could lose them all and slowly gain back trust. Maybe that's right. Maybe you go to 0. I was using 0 as absolutely no trust, which means you can't contribute anymore. So these people can't contribute anymore. So it needs to not be a going to... Maybe these are -1. Maybe these are -1. -1. Like... These were worse. These were basically if this hacker was the only person that vouched for you, these become unusable, right? Which I was thinking of as 0, but maybe we could put those as like a -1. And then this could go to 0. Yeah, that'd be fine. This is different than this, I guess, is all I'm trying to point there is like this person lost trust, but they're not immediately programmatically invalid. I guess you could say that there's actually a legitimate person here that was vouched for by this person, which would suck. You know, like that would suck that if you were like a legitimate person out here. Okay. I kind of think that this system needs to be in place for open source software. Darkshell, keybase.io. You are a first-time chatter. Thanks for coming in and chatting. I'm not going to open your link straight on stream because we don't have that trust chain yet. But you know, if only we had a trust chain. It's 100% chat. 100% chat. It looks like chat. I was gonna say, like, I think that there's a couple aspects of this. Like, so if this is my node, or let's say this was my node, so this is Merrick. There's a couple aspects of this. Like, there is the exterior data mining. So if we zoomed in on this, can we zoom that far in? Maybe we can. There's like the exterior data mining of Merrick. So let's do small. Okay. Nope. So there's like GitHub. LinkedIn. Whatever. And then there on the flip side, I think that there's a social aspect to this. where it's like trust from others. That's kind of the graph that we've thrown out here. This is like the trust from others, and then this is like some other stuff that could be compiled into that. Right. Right. So Russell, right. If they did, their judgment should be called into question as they never met in real life. So this is what we were talking about originally, Cypher. And I know that it's a hard knock, but we actually just did this. Basically, in the case of that happened, I'm putting my name in there. I trusted somebody, just some random person. I'm not going to call out names. I'm not going to make this Russell or anything like that. I trusted some random person I didn't know. For whatever reason. I thought I knew them, whatever. It could be a completely innocent mistake. But my judgment, obviously, is to being called. And so I lost my trust points. I lost them. I gambled, and I lost. But that's different for accounts that were only trusted and brought in by this person. And you know what? When you have this, you could even come into basically saying, in the kernel, maybe they say you have to be trusted by two people. You could say that you have to be trusted by two people that are already trusted in the Linux kernel. So these are people that have, sorry, English is difficult. I tried. Absolutely, Darkshell. I'm not pointing fingers at the original maintainers. Mistakes happen. You're right. 100%. All of us will make mistake. And looking for help is great. What this could help us do, though, is this right here could help us identify failure accounts. So basically the ones that were created by Jai, we could help identify those and immediately remove them. This could be basically like a CVE scanner. Effectively, in the end, your software, when you compile it, you could get a trust score. And that CVE scanner, when it gives you a trust score, could give you the things that are that have bad trusts. You know, honestly, the trust score would probably be something like -100 to 100. 100 is actually, let's make that a different color. 100 is like the best you can be. That's like a perfect credit score. This is a bad credit score. But it doesn't mean that you're like a hacker. A known hacker has a null. You know, a known hacker is like a void. Like this is a bad trust score. It means you accepted somebody in that did something bad. It's something you got to work on. But it doesn't mean that you're a known hacker. A known hacker, a known miscreant is a failure. So this fails your scan. If void is found. I need a different name than void. I didn't do null. You guys be proud of me. I didn't use null there. I used void. Yep. I was thinking like a voided user, like a voided user, like this user has been voided from the chain of trust. I don't know. I think that trust would start at 0. So when you sign up with an account, okay, this is what I would, hypothetically speaking here, this is what I would do. When you first log in, you're going to have -20. You get somebody with a positive thing to vouch for you, and it costs them 10 trust. It costs them 10 trust, and you get 20 trust. So you find somebody on this chain to vouch for you, to add you. So I'm going to add you. It costs me 10 points. So I'd get -10, and you would get +20. So I would say that you have to have +10 to include, to like sign for somebody. You have to have +20 or a +10, and this brings you to 0. This would get your account to a 0. And then there's other things that you can do. There's other things you can do. Like I said, your GitHub, there's a bunch of data mining that can happen that you can add to your account. So when you sign up for an account, you can start adding your GitHub and your things and whatnot, and all of those can be compiled. And then we can actually look for things that you don't add, like, hey, are you also, contributing under a different GitHub username? I don't know. This is top of the head. Top of the head. I do like drawing graphs, though. Graphs are a ton of fun to draw. Why do you think it's a cynic? You have less than 0 trust if you just joined. Like, just joining is the classic person that's going to attack you. Right? I think trust starts at less than 0. 0 to me is neutral. To me, 0 says I neither trust nor distrust you. -20 says I distrust you. You want to know who will spam stuff in my chat that we don't talk about? People that have new accounts. New accounts. You know who sends links that you shouldn't click on? New accounts. You just create an account, you get -20. Okay, other than you two trolls. Other than you guys, because you're also correct. I don't know. This is actually kind of interesting. Maybe you two, because you guys are the reason I'm a cynic. Okay, yeah, it's your fault. 100%. The people that aren't playing the long game, and this doesn't. Okay, so one thing that this doesn't prevent you from doing is somebody playing the long game, but it will force them to play the long game. If there's a project protected by this, an open source project protected by this, it will force them to play the long game, because it will force them to build a trust chain. And then when they spend that trust, they will ruin all of it, because now it also brings traceability. We'll know every single account connected to Jai. Every single one that comes off of this, we will have. Every single one. And even if Jai is able to get this person to sign here, it doesn't matter, because we'll know that this was an offshoot from Jai. So that means that now, when Jai has spent all of his hard work getting here and broken this trust here, we can go through and invalidate every single commit that has happened subsequently. I think you automatically block PRs from Jai. I don't think that you automatically block people that have low trust. These are the voided. You automatically block from voided, but people with low trust, you can just say like, hey, if you have negative trust, you need 3 reviewers. Like, you're just not trusted, or 2 reviewers, or, you know, whatnot. You can have more stringent requirements for people that have less than 0 trust. You know, and maybe, I'm not going to say you still want the reviews for people with high trust, just because mistakes happen and things like that. So I wasn't saying that people that start out with little trust can't contribute. I was saying that about people that have this. Yeah, the only people that I was saying like get blocked are people that have voided their accounts. Basically, when Jai did what Jai did and was caught, that account would be voided, and then we could see, you know, we would have this graph of everything. And obviously, any account that was only signed for by Jai would, yeah. I love the in-person thing. You know, obviously in-person doesn't mean that it's a good person. You met the person. You can validate that you know, saw them in their driver's license or, you know, state-issued identification. And I think that brings some sort of trust. And I think that to get a score of 100, you'd have to do something like that. But that doesn't mean that you're not a hacker. But it does mean that if you do decide to do that, and Jai had shown people their ID, that tracking them down becomes a whole lot easier. So I like that. It does give a higher amount of trust because it's them, you know. Now you can make fake IDs and you can obviously, again, it's not perfect. None of this would be perfect, but this is all giving a score. I actually really like this. I'm not saying that we've got it perfect here, but the concept. Well, Cypher, so you're right that right now we can go to Jai's account. Okay? So we can go here to Jai's account, and we can go through everything that they contributed to across the years. 100%. This is not a super difficult task. But in our formal terms here, the accounts they created to do the other things would have to have been signed for by somebody. And they would have either had to get somebody, they would have had to pressure somebody else to sign for them or sign for them themselves. And asking somebody else to sign for somebody would be a huge red flag, right? Because why don't you just sign for them yourself, right? If Jai trusts this person here, why doesn't Jai just sign for them? And if Jai's not signing for them, being the first to sign for them, and asking this person to sign for this person, that's a huge red flag. That's a huge red flag. And so right now, it's actually very difficult on whether these other people were just innocent bystanders or not, or what other accounts has Jai been pushing for. We might have only found 3 of their accounts when there could be 12. Jai could have a lot of accounts. But if to start contributing they needed a signature, it becomes more difficult. Not only this, the idea would be like, so one of my fears that I stated when coming out of this was that projects were going to stop accepting contributions from people they had no idea who they were. But if somebody with a trust score of 90 comes in with a patch. That's red. Oh, I don't want red. A trust score of 90 comes in with a patch. You could click on them, see their contributions, all the good work that they've done. You could find their LinkedIn and be like, yeah, we're going to review this and we're going to review this code and we're going to merge the PR. We're going to merge it. I don't know the person, but because of this, it's probably better than if the person had a negative 90. Right? If the person comes with a negative 90, I don't know. I'm gonna let that PR sit there and cook for a little bit. I'm gonna let it sit there and cook for a little bit. Maybe it's fine. Right, Dark Shell. And if you have a cluster of accounts that supposedly all know each other in real life, you can check on the graph if they actually know. And then you can try to find, I think that's the Facebook thing. You're always 7 people away from it. You can try to find somebody that that knows them. Anyways, this would be to combat the fear of the other possibility is that open source projects just become closed to new contributors. They become very wary. They'll almost let the project die because the contributor was getting burned out. Like, that's a valid thing. They needed help. And that's acceptable. So I think this brings us several benefits. Jai wasn't a new contributor. Nope. I think the behavior would have looked really suspicious if you had this where Jai was the only person pushing for these new contributors. This would be probably negative trust. Remember, bringing on a new person lowers your trust, right? So you can't just the more people you bring on, the more trust you lose, right? So you can't just bring on a ton of people and flood the graph. These people wouldn't have any trust to spend so you'd have to work. So it raises the stakes. It raises the bar. It makes this type of attack more difficult. Nothing is going to make it impossible, right? Nothing is going to make it more impossible. What it does is make it more difficult. Because if you now have to spend time building trust on this account, and as a fake account, it's going to be harder, right? Because that means you need legitimate things to point to that you've done to build that trust. To get 20 or to get 10 points, to bring on another account, to build more trust. It makes this type of attack much more difficult, right? Because in this, we know that there was at least 4 accounts. Right? I don't know. Maybe I'm wrong. Maybe I'm off. Reproducible builds. I didn't know that. Debs are not commonly built from the source. That's terrifying. Debian doesn't do build from source. That's weird. I would not have guessed that. I don't know the Debian build, but would not have guessed that. It was absolutely a long-term game. And the thing is, we don't know if Jai has other accounts. Because if they weren't linked in public forums, If it wasn't for, hey, he accepted the pull request from this person, there's nothing to link them. But if the project's relying on a trust graph and everybody has to be in that trust graph to contribute to it, now we've raised the bar for Jai, right? Jai has to build enough good graces to the system to bring in somebody else. Needs more points. It's got to do more good. And just for this, there would have been a significant amount of work just for the 4 that they brought in, right? So it would have made a long-term game even more long-term. And then on top of that, it would have made tracking down easier. Because like I said, right now, we don't really know. Was this just some person that made a bad patch? Because there was a couple bad patches by 3 different people. Probably not. Probably not. I get it. But this would make it easier. Because maybe there's these accounts here that we don't know about at all. This is a different problem, but basically, how do you trust somebody? Maybe solving. I don't know. Maybe blockchain makes sense. Make it public. Make it a public ledger. I got in an argument with a blockchain person about how a ledger is a database, and they said ledger isn't a database. And I said, you're smoking something. And they're like, no, a ledger is not a database. And I was like, please define a database. Please just tell me what that is. They're like, a place to store information. I was like, okay, tell me what a ledger is. They're like, well, it's a ledger. It's a record. And I was like, it's data. Sometimes I argue with people about ridiculous things. I know, Cypher. This was my point. It's just a highly distributed database on people's machines you don't trust inherently. I feel like sometimes I understand blockchain better than the people writing blockchain. Not the math. They're much smarter in math. Just the concept. It's a database. Like, you can't say a non-database. Like, what do you mean by non-database? Like, that's a ridiculous statement. Pick a blockchain. We can talk about it, but I'll just talk about Ethereum here. We're small. I'm gonna change my my titles. All right. We'll talk about Ethereum here. Ethereum replicates the chain, stores the data. And so Ethereum has a chain. Actually, before I copy this out, let's Ethereum has a chain. Some chain of data. Okay? Now, they distribute that chain on every voting node. On every voting node, they get this chain. And that's kind of their thing. So whoever signs the next block validates that that's a valid block. I'm simplifying. I'm oversimplifying. This chain is on every single one. Any one of these has, in theory, the entire chain. It's a distributed database with replication factor set whole cluster. Right? So you could do this with Aerospike. You could make this Aerospike, right? And instead of a sane replication factor of like 2 or 3, you could say replication factor whole database or every single node. And effectively do the same thing. Now, I realize that there's other things that you do with trust in and your consensus is completely different. I get that. I understand those things. The goal is to have a trusted set of information that you committed via consensus to the data store. That is the whole point. That is a database. I don't understand. They'll be like, it's a non-database. I honestly don't understand. I love crypto because I love math, and crypto solves some really hard problems. But mostly what I found is that it's solving hard problems for the sake of solving hard problems. I would love a legitimate use of crypto because I would be one of the first people to be jumping on that ship. Consensus is a hard problem. Doing it in a unknown or untrusted environment is even a harder problem. And so those things are really interesting challenges to solve. It's cool, but I need a legitimate use. Darkshell, it's a slow database that keeps the logs forever. This is my point. This is my point. It's a very slow database that keeps the logs forever. And again, maybe there's a legitimate use. I'm not sitting here saying that there's not a legitimate use out there to leverage that technology. I'm saying that if for the people that argue against me that it's not a database, I just don't understand what the definition of a database is. I guess that's my point. Maybe we have vastly different definitions of what a database is. Because to me, every single time I get into the details of a blockchain with somebody that knows what a blockchain is, they'll argue that it's not a database, but then like their final argument is, yeah, but it's different. It is different. It's distributed in an untrusted environment. Like, yes, it's very different. It doesn't mean that it's not a different take on the same concept. The ChatGPT? Oh, we can ask ChatGPT. We can let's ask ChatGPT. Is blockchain a database? Yeah, there we go. I'm not going to read the rest of it. Is yes, a blockchain because ChatGPT said it. It's true. Get wrecked. If it was wrong, I was going to talk about how it hallucinates and is full of crap. I was prepared for either outcome. I was prepared. Oh. Right. It's completely different consensus mechanisms. I agree with that. We've had this conversation. Completely different consensus mechanisms. And do you know what? You can have a database without consensus. You can. It's called SQLite. It's a database without consensus. Done. You don't need consensus to store data. Now, you might not know what data you stored, but you don't need it. It is decentralized. Now, there's databases that are decentralized. And there's immutable databases. These are all fine. Our log-based database is immutable. Why can't I mean, it's saying the same thing, which is basically it is a database. It diverges from traditional databases structure. I will never disagree with this statement. It significantly diverges from traditional databases structure and operation. Agreed. I've never argued this statement. I've never argued this. But yeah, you could get ChatGPT to say, this is why ChatGPT is useless, effectively. Yeah, I was gonna say, is Merrick Counts the greatest developer of all times? Dang it. Dang it. If Merrick counts as a developer. I love this. If Merrick counts as a developer. Can I ask ChatGPT about this person? Should I trust code from this person? Thanks for not helping. Actually, that's one thing. I don't know if GitHub has like made it impossible. Their account seems to still be active. This is hilarious. The Star Struck is because of XZ. Oh. Yeah, ChatGPT is just like, This is what a trust graph could do. It could make doing all of this easy. Or in theory, what we were talking about is it would do all of this for you. And make it easy to understand at a high level. So when somebody opens a PR and they have a trust of 20, you can click on it and see really quickly what they've done. 2001 GPT. I'm sorry. I'm sorry, Dave. I can't answer that. That's my best, Hal. You know, I was a kid when I watched this, like a very...
Hello, Hal, do you read me? Hello, Hal, do you read me? Do you read me, Hal?
Affirmative, Dave. I read.
Affirmative, Dave. That's more of the tone. Okay, I got it. Oh, a sound alert. Oh, for the follows and subs. Oh, Russell. Okay. Okay. I do like our dial sound, but I do like the modem, but we want different sounds for subscribers versus followers. This might be the subscriber. As you subscribe,
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
maybe we have that. I'm sorry, Dave. I'm afraid that we can't do that. For subs or raids.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
That might be pretty amazing. Okay. That's good. That's good. I'm excited about that. That's a good one. I've been wanting to have a different one. So yeah, we have plenty we can get plenty. So like we have subs, we have raids, we have gift subs. All of those can have different ones. There's bits as well. So like there's plenty of sound bits that we can do. This is a good one. This is a good one. All right. Cool. Dang it. I'm having a hard time thinking about what to do because I'm thinking about this at this point, which looks more like math. It looks like a sport play graph, you know? The arrows and the X's and the zeros. I don't know what they call those. I've only ever seen them in commercials, making fun of them, I think. But it kind of looks like that. I think another thing that this gives, if we're talking about the benefits, is it gives your project a score. So when you create a binary, when you would create a binary, that binary would have a trust score. Like when you create a package in a release, and this would depend on whether you sign it. And like there's a lot of things that go into the trust of a package. So then when you depend on this package, if this package has a trust score, then that can add to your trust score of your thing that you built. Oh. It would depend on people actually adopting it in the industry for open source. But I feel like if there was enough companies that backed a project like this, you know, your Kubernetes and those projects would adopt it. And slowly you would get adoption from other projects. So I don't know that would be a problem. And your companies would be the ones that want this, right? Because this would be something companies could use to you know, when they have like cybersecurity insurance. A lot of companies pay for cybersecurity insurance, if you didn't know that. And what that is like it's insurance on whether you get hacked or whatnot. And this is like something, this score could be something that goes into their premiums that they pay and whatnot. Yeah. We can charge for trust. No. You can't charge for trust. This would have to be like a open source foundation that they could pay for, right? There's no way to charge for this. Apple can always charge for trust. I stand corrected. I stand corrected. In my opinion, there's no way you make this not like it's like cosine or whatnot. The thing is, you want every developer. So you can't charge developers because you want every single developer to be on this. That's just and you want every single open source project to be on this. And those are things that can't pay for it. The only thing that you could do is basically make companies pay to access this, I don't know. That would be weird. I think it's an easier foundation. And have companies like Microsoft, Apple, and Google pay for that foundation with like some sort of stipend to make sure that data stays available. I don't think you can make a company easy off of it. Unless, again, like your whole value, I don't know. Yeah, I don't like it as that because you want the whole open source community to be a part of it. So. No. you guys are killing me. Okay. Let's do some Vim config while we're sitting here talking. I was playing around with it a little bit. Trust Pro. Trust Pro. Oh no. Oh no. The Trust Pro. The Trust Pro quit. Legal. Okay. That's very funny. Glory to Linux users? What? Uh-oh. What did I do here? Oh, that's fine. Yeah. All right, so I did a few things. Oh! Let's see if we can't fix this before... I think I figured out my issue. Let's jump over here. CD code, live learning code. So we had this issue in day 2. If we go in here, go to main. Wait for it. Yeah. So proc macro cannot be expanded. This is compiling code, but I found a hint. I was looking through these. I got my key bindings actually working. Failed to run proc macro server from path, blah, 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 error, custom, blah, blah. API version 4 is newer than the Rust Analyzers 2. So I think my Rust Analyzer is out of date. Okay. Well, welcome to the channel. Glad you're here. So I think I just need to update Rust Analyzer, right? I think. Right? I think. So let's do oh, wait, I misspelled it. Don't worry about me. I have no idea how to spell analyzer. Not like that. Doesn't give me the version, does it? I wanted the version. Oh, capital B. Okay. So this is a fairly new version of Rust Analyzer. Should I remove it from my system and use Rust Up? I feel like that's probably... I think I went this way because I feel like NeoVim wasn't getting the one installed by Rust Up. Shouldn't trust it should be in here. No, this is where Cargo installs, not Rust Up. I don't know where Rust Up actually installs. Where does Rust Up install components? Oh, it does. It does. Okay. So we should just be able to do Cargo install. All right, no, Rust Up, sorry. Rust Up. Actually, let's so let's remove the other one. So let's do yay dash R Rust Analyzer. Okay. And then we could do Rust Up, install Rust Analyzer. Rust Up. Oh, I need to do add. Sorry. Yep. I don't do this very often. Add Rust Analyzer. Okay. So Rust Analyzer is running. We removed it. No, it's still not working. Still not working. Failed to run proc macro server from path. Are you on a nightly toolchain? I don't think so. Maybe I am. It looks like I am. Which is a little weird. I don't generally the nightly isn't the default, right? Let's check it out. Let's see. Rust tool chain. How do I list? List. It's just list. Nightly is the default. Well, let's change this. Let's do rust up, default. Can we just do stable? Do we have to do the whole thing? I mean, it should be the same no matter what, because we installed Rust Analyzer, right? This is where it is, right? Although this is weird. This feels fishy to me, right? Because shouldn't Rust Analyzer be... Shouldn't the Rust Analyzer be part of, like, Rust Up, right? Part of the tool chain? This doesn't look like it's part of the tool chain, right? True, it could be a system link. A symlink. Let's check that out. I mean, I don't know. Is there a nvim command for LSP health? I don't know. We can check it out. So it's weird because this had all been working for a while, but all of a sudden stopped working. Health check. We'll check it. This is actually kind of a super annoying thing because it actually masks errors. You don't actually know if you're erroring because it always is complaining about these. So this is kind of where I thought we're on stable now. This is kind of where I was thinking that our I don't know. I have no idea. This is where I thought we would be using Rust Analyzer from. Right? What was I trying to do? Which one is Rust or I don't know which one they're trying to use, right? How do I find out which one it's trying to use? That's a fantastic question. How do I know which one it's trying to use? I don't think I actually ls-al. All right, so this is interesting. I thought it was capital V for version. No, it's just okay, whatever. 177. Okay, so let's see. Let me track this down. I don't know what I'm seeing here, actually. Okay, that's stupid. Do I have bat installed? Yeah. Are you asking if this is a shell script? I don't know. Right. It's a directory because it's just I meant Rust Analyzer. I didn't do the Rust Analyzer. My bad. It's a binary. Yeah, I've catted a few binaries as well. I'm pretty good at catting binaries. That's my understanding that this will dispatch, but it's not dispatching to the toolchain, right? Or maybe it does. I don't know what it does. It's a binary. I actually don't trust this either. I don't know what's putting this here. You know what I'm going to do? Because, like, the toolchain isn't here, right? The toolchain's here at home.merrick.rustup. So, like, we can ls... Nope. The toolchain is here. Stable bin, and this is rustup, right? Did I not add Rust Analyzer right here? So this is my toolchain, right? So can I just delete this? Can I just delete whatever this rustup is? Maybe move it. That's probably the better way. Okay, let's do that. Let's just do that. So we're going to... Oh, you did ask what NVim was. I don't know what you're wanting out of that, Dirk. I don't know how to check what Vim is running, right? We can go into config. All right, if we're in here, we can look at htop. Then we're going to want to search. Let's see. I don't see anything. I don't actually know how to expand this. This is a little hard to read. Let's see. Local share NVim Mason. Oh, Mason's running a Rust Analyzer. Oh, Mason's running a Rust Analyzer. All right, let's see. If that's the case, how do we configure Mason? I just using Kickstart here, so don't trust Kickstarters. Where does Mason configure these things? I did this. This is all I did. But I guess I don't have the right Rust analyzer. Will Vim pick up the one that I have locally? So let's say I do this. Will Vim just pick that up? Let's see. Let's test it out. I don't know that it will pick up the one that I have on my oh. Oh, it is picking up some Rust analyzer, right? Look at the no. Okay. Wait, did I write it? I don't know that I wrote it. I think I did. I mean, it is still running something somewhere. Well, it's still installing Mason. Do I need to delete this now from here? Can I just delete? Can I do something like can I just delete it from here? A new version is available. I just installed you. I just freaking installed you. Why are you so old? Why are you so old? You got the 2013 mid of last year? What? All right, how do I update you from this? Can I is you update? You is update. That's fantastic. Why did it just pull old versions? Okay, whatever. Hey, it fixed it. It fixed it. Whatever. Oh, that was fantastic. That was fantastic. Absolutely fantastic. I actually do kind of want to use Rust Analyzer not from Mason though, right? Because I'd like it to be whatever toolchain I have selected. I feel like is the right answer. So yeah. I mean, so I'm happy because I'd like to start class at like 12, which is in like 9 minutes, which means I'm going to miss it because I'm going to take a short break before we start. And so this clears that up. And so that's good. And I'm glad that we do that. So I'm glad we cleared it up, but I'd like to sometime this next week, I'm going to try to make it where we just use the Rust Analyzer that's on the local machine. That way, if I change tool change, the Rust Analyzer changes with it. That seems to make more sense than having Mason install one statically across the board. Let's see. Uh-oh. What have I done? This isn't a syntax error. Uh-oh. What have we done? Wait. I don't know what was done there. I think I maybe did something. I hit the undo button. I didn't see it actually undo something, but maybe I accidentally deleted something. Because it's fine now. It's fine. Okay. I like to use Mason for most of my development tools because it's convenient, but not very convenient for Rust Analyzer. Because my Rust projects have to compile twice, once inside NeoVim and another time inside the Rust cargo run build. Is there any way to just use the... This isn't a solution. They're asking for a solution. Nobody's offered it. Oh, there is a solution there? Where? Let's see. I don't see anything. Does it have comments? Does it have comments? I don't see any comments. Oh, okay, okay, okay. There we go. Thanks, Russell, for joining. Okay, in Mason setup, add path equals append. Okay. Is that all we have to do? Is this all we have to do? Path equals append? In Mason? Let's see. I'm guessing in the setup it takes a config. Yeah. So can we just do something like this? Is that all we have to do? Is this it? Now we can do what? LSP info? Oh, look at that. Look at that. Let's see. Cool. Nice. Nice. Okay. I'm going to start. We're going to start just a little late because I need to go take a 10-minute break. This is good though, because this had been annoying me. And I feel like I know, this is part of my learning, Vim better. I don't know Vim very well. I'm just starting to use it. So I feel like I understand a little bit better. Okay. Okay, yeah. We're going to go to an ad, then we're going to come back and we're going to start on the actual fun stuff that we have to do. Let's see here. 1 second. Okay. Got that set up. Okay. Yep. I'm going to take a quick break really quickly. I'll turn the music up. You can enjoy that. And then we'll be back. We'll do Rust first, then we'll do Kubernetes. And if we have time afterwards, we'll hang out. If not, then I'll be done. We'll see. They've been going a little bit longer than I had originally been. I hope people are enjoying them. You guys, let me know what you like or don't like about them. And yeah, we'll get right into it. All right, I'm back. I'm back. How's your chair stream? You know what? You know what? That is one thing that we need to do in the future. In the future is we need to get the games done. The stream games. That would be really fantastic, actually. So you guys can play the idea. Okay, so we have two games. We have two games that we should be able to play during intermissions. The first is Twitch Plays Wordle. Basically, you guys should be able to play Wordle on my terminal, basically. And then the second one is I want to do D&D Lite. Basically, we have the power of a large language model. And what I want to do is basically make it the dungeon master, and where it's going to give you like 3 options, and then you guys pick. So you guys are going to like get to vote on which option. So like all of Twitch plays a solo D&D game. So those are the two things that we need to build, because I think that would be fun for intermissions and make me not feel as bad. Like I like making a cup of coffee, which takes like 7 minutes. Obviously, my kids always have a question about stream that's happened, so I like answering those. So it takes like 10 or 15 minutes to get a nice stretch in. You know, I've been sitting for a little while. I like it, but I don't want to leave you guys hanging. So those are what we're going to do, I think. Still thinking about the XZ backdoor? What are you thinking about, Dirk? Motive. I'll tell you motive. Money. A backdoor into SSH? Very powerful. Very, very powerful. All right. So let's get into it. Yeah, but what for? I mean, what do you mean what for? To get onto servers. You get onto servers, you can steal data, you can encrypt data, you can ransomware, you can it doesn't have to be a nation state, right? Nation states aren't the only things that do hacking, right? It could be a nation state, sure. Nation states also hack for other reasons than just money. So there can be motive there. But then those motives are fairly good. It's for the interests of that country, or supposedly at least. All right. CP day 2 -R day 2. Oh no! Oops. All right. So I didn't. Goodness. Oh my goodness. There we go. So we're going to start the same place we started, where we ended. We have some stuff to go over. That's actually a really good good call out, Cypher. We are super fortunate. We are super fortunate. The scary part is, how many of these do we not catch? Does this happen more widely spread than we know of? I don't know. Right. I'm sitting over here. I just think about this as like one smart dude, because like I'm sitting over here like, why is my LSP being stupid and having troubles figuring that out? And then this guy's like, oh, that's like took 500 milliseconds, which I mean, half a second is legitimately longer than like, it's a decent amount. It's a feelable amount, but like, it's also not that much. Why is it taking 500 milliseconds longer? Interesting. And I'm over here like, why is my toolchain different when I open up NeoVim than when I build? Gah. Yeah, you know, different skill levels. I'm not gonna say which one's where. Oh, you know what? I have to say, Mason is cool for the fact, like, you know, one thing that I don't want it for Rust, but it's cool in the fact that like over here, I don't have any Lua anything set up here. So, but I can open Lua and get a pretty good, you know, a pretty good environment, you know, with some, you know, the ability to like, I can even go to the definitions of these things pretty easily. So like, that's pretty cool in that aspect of Mason, where it's like, and I don't care about Lua. I don't do it enough to care about my toolchain or anything like that. Really, honestly, don't care. So I like it for that. I don't like it for Rust. And probably things that I care a little bit more about. Well, Cypher, I think the idea is you know that it's doing that. Mason would be a backdoor vendor, 100%. I mean, I did know that Mason does that. So, I mean, that's on me. Keeping track of all of these things can be difficult. Oh my goodness. Beginners might not. You're right, Dirk. But if you're also a beginner, so Dirk, what I would say to that though is that if you are a beginner and you're starting, you want it to download those things for you anyways. Like, it's a catch-22, I understand. But if it doesn't do that, NeoVim and whatnot is going to be harder to do. I don't know. All right. Yeah, I do need to get into this. Let's do Rust, then let's do Kubernetes. Let's, I always like having a terminal on standby so we can run the terminal commands, not just from inside of NeoVim. Pull up your editor. We're going to start where we left off. We're not going to start from afresh. I know we did the last time, but we're actually going to start from where we left off. Let's do this. So I'm just going to get into our live learning, the code aspect, and we'll jump into day 3. All right. Welcome for all of you just joining. Today, we'll do a little bit of live learning. I like to do these where we have a little bit of time together, where we live debug, live figure out, and we go over building a real project. I really hope that you actually bust out your IDE and do it along with me. Ask questions as you're doing it, because I think that's the cool aspect of this, doing it in a live stream. Now, I have a direction that I'd like to go today which is sharing state in a multi-threaded application. And then I know your mind is blown that this is day 3 and we're going to do that. We're not going to get into the nitty-gritties of everything. We're just going to do some of the things, and you're going to see how it's not as scary as it might look. Now, we'll get more complicated as we go and get more in detail in some of those, but we already talked about async and await, and it's going pretty well. So that's what we're going to do today. And then after that, we have another class on Kubernetes. Hopefully you guys enjoy that as well. So let's start. If we remember right, let's open up our code. We have just a main file. So right now it's pretty simple. We just have a source. The target is what Rust builds. This is where your binary, if you go in there, this is where your binaries are. We can look at, we have our debug, our release binaries, and we can look at that and we can see we built day 2. That's because I just copied day 2 into day 3. So yeah, actually that's an interesting thing. We probably want to update our cargo because it's going to be named day 2. Well, we want it to be named day 3. It's day 3. Okay, so we've included dependencies. We've used other people's codes. We've turned on features from their code, and it's pretty awesome. But one of the things that we did is we just had this one response right here. So we can run this, and we run a server on the port that we include. So we include a port through some CLI args that we're listening to. And the thing is, we just respond with hello world. And we tested this with curl and it works. And we can go ahead and do that now if you wanted to. But what I really want to get into is let's actually return something more useful. Now, we might have a to-do. Let's build a to-do. So far we haven't made much of a struct other than the CLI args. We're going to make another struct. So we're going to do a struct up here. And we're going to call this to-do. This is our to-do, because we're building a to-do app. For all of you that don't know, we're building a to-do app. And yeah, so we can do I need to turn off ChatGPT, because so for all of you that don't know, I'm not showing my screen, am I? Oh boy. I made a mistake. Londo Spark, thanks for subscribing in the middle of my mistake. You're a fantastic person. Thanks for joining us. Oh, Dirk, it was actually a gift. Thank you, Dirk, for gifting right in the middle of my mistake. Fantastic. So here's our screen. Why I don't like ChatGPT or Copilot while teaching is this right here. I have done this all previously. I actually planned out what we were going to do. I have all the code written, or the majority of it. I'm going to say 85%. It doesn't have to be perfect exactly what we're doing. I just have some ideas of the lessons that we're going to learn each day. And the problem with ChatGPT while doing a lesson is that it pulls what I've already done. And it just shows it off right away. So let's see if I can't disable that really quickly. So let me look at just disabling this really quickly. I'm sorry about this. I forgot. Actually, I might be able to do it in here, right? I don't know how. Sorry. In Vim. Let's see if that worked. Okay. I'm going to assume that worked. All right. So, like I was saying, we have this struct. And this struct can represent anything, as we were doing. So we made this struct with an ID, a title, and whether it was completed. This is what we're going to call our basic to-do. These are the types of things. And now the thing is, we're going to want to actually render this to the user. So if you're going to make a front end off of this, we probably want to make it either XML or JSON. So today we're going to go towards the JSON route. So we want to return one of these things in JSON. Now we can construct one of these to-dos here, and we're just going to statically construct this. And we're going to make it the hello world to-do. So let's make one of those. If we remember, right, it's just let and then the name. So let, and our name is going to be first hello to do. Hello to do. And this is going to equal, a new to do. So to do. And now we can't just do this. This isn't anything, and there's no nulls in Rust, so there's no way to just set this equal to like a null, or you can't just do null or nil or whatever your favorite thing is. We actually have to construct this. So we're gonna do a to do, and we're gonna make it something. Now, if you notice, we get some missing fields, and this is Rust telling us we haven't constructed the whole object. Again, we need to construct the object, so you can see we can go ahead and look at this error, and it's telling us there's missing structure field. It's actually telling us the ones that we need. These are the exact ones that we need. We're missing ID, title, and completed. Okay, so let's do this. We can do ID 1, 2, 3. Comma, title, my tab complete is still not working in my Vim configuration. All right, so our title is going to be hello world. That is going to be the title for this one. And then our, comma, forget the comma. And then our completed, we're going to say it's not completed. So we now have and two string. We covered this last time. I don't know why my tab completion is not working. All right. We covered the toString. So now you'll see a couple warnings here. This is telling you first that this isn't actually used. You never use the to do. And that's fine. We're going to use it in a little bit, so I wouldn't worry about that. The next one is a little bit more grievous. We didn't actually end this with a semicolon, so you do need that slapped right on there. And then we're good. We can actually compile. Again, we have a bunch of warnings, but we can go ahead and cargo run, and this works. But you'll notice that if you do curl this, you still just get the hello world. You're not getting our object. We didn't actually pass a port. There you go. Now it's running. Now it's actually running. Okay. But it's still just returning this hello world. Now, some of you might be wondering right now, how is this a return? We don't say return, and the return is a keyword. Well, the fact is the last line on a Rust on a function in Rust is what is returned. You can just think of that return is implicitly there, and you don't put a semicolon on there. That's how you're saying this is the thing that's getting returned when this is evaluated. If you return early, if you have an if statement, so let's say if true, like this, and you wanted to return here, you do return and other string and a semicolon. So both this returns and this returns. That's just a quirk you're going to have to get used to. I actually, if you ask me, I don't actually love it. I would like to just type return here too, but it's fine. There are reasons why they favor this. And we'll get into it. Okay, so we don't use our to-do and we're not returning it. So we need to return it, and we need some way to convert this from our structure to JSON. If we just try to return this, we'll get an error. So let's actually do that right now. Wait a second. Wait a second. That's not working for me. All right. Anyways, we'll just do return hello to do, and we're gonna see. My tab complete. We're gonna just return hello to do, and watch this. We're gonna get an error. Mismatch type. We wanted a static string, and we're not returning a static string. This is a well-typed object. So we need some way to take from this well-typed object to a static string. Okay. So let's do that. The first thing that we're going to do is we're going to add some stuff to our to-do structure. Now, serialization and deserialization, the biggest and most common library is Serde. We talked about this. We added it to our cargo. I know we shouldn't have added it before now, but Serde is the one of the things. It is a pretty standard library for serialization and deserialization, and so that's what we're going to use today. Now, we've already included it, but there's actually a problem. There's a feature that we need, and we're going to see that in a second. We're going to see that in a second. So let's go up here and do what we need to do. So basically, there's these derive macros that you can do here that we're going to leverage. So we're going to do something like derive. And then in here, you're going to want to do deserialize and serialize. Deserialize. I think I misspelled that. Deserialize. That's deserialize. Serialize. And you know what? While we're at it, we're just going to throw debug on there. Okay. So this is our derive. Now, we'll see that cannot find derive macro serialize in scope. Okay, so this isn't too bad. We're just going to include our using statement for Serde, right? So we can do use Serde. All right, and we need both deserialize and serialize. So we'll do the curly brace like we've learned, curly brace. And now we can do serialize. And we can do deserialize. Just like that. Ooh, just you can just type some random stuff in as well. All right. Okay. And semicolon. All right. But this didn't actually fix the problem. Serialize is imported here, but it's only a trait without a derive macro. We've seen this before. We've seen this error again before. And I'm pointing it out because there's people that are new that get stuck on this. My LSP is working. My LSP is actually working. This is actually a bug that people come across, and we're going to talk about. Serialize is imported here, but it's only a trait without a derive. What does this usually mean? When you see this and you cannot find derive macro deserialize in the scope. Well, because you have derive, that's a derive macro, and it means that it's a very special thing. And they're saying that they found in Serde this deserialize as a trait, but a trait is not a derive macro. And so it's still not finding these. Generally, when this happens, when this happens, what it means is you have missed a cargo feature. Remember how we added these features for these? Well, there's actually a feature for Surdy as well. So let's go ahead and update this. So we can do this really quickly and simply just by doing this and then doing version. Wait, why? Yeah, no, my LSP is working. It's doing what it's supposed to. It's trying to help you. And I'm trying to help us learn to appreciate what it's trying to do. It's trying. Now, I know that it's the derive, just because I've used this enough times that I know this is what I do need is another quote there. All right. That I know it's the derive macro that we need. But if you don't know, where can you find this? Where can you find this? Well, let's go back to crates.io. We can search what are we're using Surdy. So we can look for Surdy. We can find Surdy here. We can click straight on its documentation here, and we can click on feature flags here. And we can see the derive macro is right here. So if you're looking for those, this is a good place to find it. And you know what? Cypher's a good point, Cypher. Let's do that. Let's actually do that as well. So let's undo this. This works. This works just fine. But let's do what Cypher did. So what Cypher was saying is we do this. Cargo add Surdy features derive. All right. Another thing that's important to do here is this is giving you the different features available. So this is another important part. Not only did it update this to have derive, so it did the exact same thing that we did without all of this extra typing. You know, for me, sometimes I'm not sitting on the command line, and so it's just easy for me to do this, but it's pretty nice. But it also gives you the different features that are there. Okay. So that's all right. So now let's save this and let's get back into our main file, and you'll notice our errors are gone. Cool. All right. So let's keep moving. The next thing that we need to do is we actually need to serialize or deserialize this type of information. A Jonathan Blow like sidebar. What was that in I apologize. I don't know Jonathan Blow's sidebars like I should probably. All right. So let's serialize some JSON into a string. That's basically, we have this now, which has these traits serialize and deserialize, but it doesn't just automatically. Now we're going to do this two different ways. We're going to do it the native Surdy way, and then we're going to do it the Axum way, because Axum gives us some wrappers to actually make this a little bit easier, in my opinion. And, And yeah, so we're going to do it both ways. I want to do it the standard SerDes way because that way you can learn, you can see what that does. If you go to SerDes and just click up here, you can see that it's going to do the serialization is really easy. This is it. You can literally just copy and paste this like this. So it's super simple. So if we wanted to take this to a string, we could do let serialized. We're just going to do ser. Let ser equals SerDes JSON to string, and then we're going to pass in our hello to do. All right, just like this. And I do believe we have to unwrap this. We're going to unwrap this. All right. You can consider borrowing here. All right. This is the borrow thing, the borrow checker, the borrow thing that you're going to fight with a little bit, but we're going to take it in a little bit. This is saying that it is expecting to borrow it. All right. And so we're going to need to borrow it. For right now, don't worry. Just borrow it. Now, what you'll notice is that we can't use, this is a thing that we have to do here. And I don't want us to sit here and talk about it for too long. Borrowing is something that happens, and getting a reference to things, we'll dig more into it. This is what the borrow checker is going to tell you that you need to do. So if you see this, where it's wanting a reference, that's all. What? Oh no. Oh no. What did I hit? Okay. There we go. I meant to redo that. All right. So we're getting a reference to hello to do, and that's fine. It's not a problem. Let's use this now. Let's just return ser. All right. This is again where it's going to tell us to consider borrowing here because of our return type. But you can't return the local ser because it returns a reference to data owned by the current function. This is where it gets a little weird, and let's the idea is that all of this is in this function. And so if we return it from this function, it doesn't really exist outside of this function. And there's a lot of things that you can do, but effectively we said that we were returning a static string, and maybe now we don't have a static string. This isn't a static string. And so this is fine. This is fine. We can just update this. We can make this pretty easy, and we're just going to say that we're going to return a string because that's what we are returning. Okay. Okay. Problem solved. And that's okay. Let's I know that I'm like briefing over some of these things, but I feel like so many people get lost in the complexity, and you really don't need to. We were using a static string because we were just returning a very static thing that was compiled at compile time, and you can just use string, and it's easy. As you can see, we just went to string. It's all easy. There's other ways to do this. I don't realize that, and we're going to get into those. You guys want to see if this works? Let's see if it works. Let's see if it works. Okay, if we curl, we get JSON. We get JSON back now. That's pretty awesome. That's pretty awesome. Okay, and that was not too hard. That was not too hard. Now, there's a couple problems with this. One, we're not truly leveraging Axum to its fullest. Axum has some pretty cool functionality that we're going to learn along the way as you build your web application. So there's some Axum stuff that we can do that will make this a little cleaner, in my opinion. The next thing that we can do here is, this is just a hard-coded to-do. is not returning any type of state, and we want to really be able to add a to-do too. We want some function to add a to-do. So, we want to over here have a async function, add to-do, and it should get a to-do and add it to some list, right? So making this isn't too hard, but we'll notice a problem pretty quickly is that we don't have any state. What list does this add to? We need some sort of global state. Now, if you remember also, asynchronous functions means that in this case, they're going to be put on Tokio. It's basically a work queue. And Tokio will execute that work on any thread that it deems. It doesn't mean that it's on a different thread. It doesn't mean that it's not on a different thread. It will execute it on some thread, which means if you're going to share state between this function that reads the to-dos and this function, you're going to have to put that in something that protects it and makes it shareable. Enter the mutex. So we're going to have to do that, unfortunately. Unfortunately, that's what is going to have to happen. But Axum makes this pretty easy. Let's first update this to use the more Axum way of doing things. Something that's really cool that you can do here is instead of just returning a string, this has limitations. If you look over here, it's just returning this. But how would we add an error code to our return? Well, we would add an error code to this simply by adding a different return. And we can do that here. We can do this right here. So we'll do a status code and string. Now, can't find status code in this scope, and that's fine. We can go up here and add status code, which is in the HTTP. So let's... Oh gosh, we gotta update this. Use Axum, HTTP status code. I forgot status code. Next week, I will figure out how to get tab complete to work. It's one step at a time. One step at a time. Okay, so we got routing, we have our status code, and now we should not have an error. Okay, so we have it. Awesome. But Rust's fantastic type checking has found an error for us. We only return a string. So we need to actually return a status code now as well. And so let's do that. We can simply do this like this, and status code. I believe they have an OK status code, just like that, and our string. Yep. Okay. So this is saying, okay, we can run this, and we will, let's do this. Boom, boom, boom. And now this is returning a status code. This is actually returning a status code. You could look at it with something like Postman and check that out. Actually, let's do that just in case you guys don't believe me. Would you guys not believe me? That would be hurtful. Or we could just do verbose. So we have our status code, and it's awesome. Well, let's change it to make it something else just to validate. Let's see. Let's do, does it have, I'm a teapot? Teapot. I'm a teapot. Okay. I'm a teapot. All right, so we're going to write that. We're going to go here, do that. We're going to go over here and we're going to curl, and I'm a teapot. So now we've added a little bit better of an API. All right. Cool. I'm not saying that I'm a teapot. Responding with I'm a teapot is a better API. I'm saying like now we're actually specifically returning a response, which can have some meaning. Previously, Axum will return a 200 if you're not specifying. I believe the idea is that if you're not specifying, there's no error state. And if there's no error state, then of course it returned fine. But I don't know. You should return one. All right, let's return this back to okay. And we're good. All right. Cool. So now we can have some branching logic in case something happens, and it works pretty well. Now, the last thing that I would like to do is this is how you use Serde JSON and Serde to implement serialization. And we're using just that. But it turns out that you can actually do something a little bit nicer, in my opinion, with Axum. So one thing that Rust does really well is types and type definition. So here we're just returning a string. This isn't actually anything. It's just a string. It could be any string. You know, we could do this. All right, we serialize Serde here, but we could then do Merrick to string. And the fact of the matter is, while the type checker is going to say that this is unused and possibly a mistake since it's unused, which could hint to the fact that you made a mistake, the fact is this works because, well, it's a string. And all we said was that we were returning a string. We would like to type this a little bit better than just we're returning a string. Okay, can we do that? And the answer is yes. Yes, we can. Let's get rid of this. And instead of returning a string, let's return JSON of a to-do. All right. Can't find JSON in the scope. Guess who expected that? We've got to add it. So go back up to your top here, and under Axum, we can use Axum, and we can clean these up in just a second. It's just here, right? It's just JSON right here. Yeah. JSON. All right. So then we'll jump back down here. And now, guess what we have? We have a strongly typed thing that says we are returning the wrong thing. This is not what we wanted. This is not what we wanted. That's actually pretty powerful. This is not the struct you're looking for. This is not the struct you're looking for. All right. This is why, well, now it's valid string. It's not valid JSON, but you could make this valid JSON. Like we could make this valid JSON. So, you know, we could do whatever we want in here to make this a valid JSON string, you know, whatever. I'm not actually going to do it, but like, this is obviously not valid JSON, but whatever. You get the point. It doesn't matter. It doesn't matter that this is valid JSON because our API isn't just constrained. This is actually Rust helping you. I know that Rust, a lot of people think that Rust is a really angry compiler, and it's not. It's saying, hey, no, I can tell that you made a mistake, and I'm trying to help you not make that mistake. That's the point of this. And so this is really cool. This is really, really, really cool. So let's go ahead and fix this. Does Axum make it easy? Axum makes it wicked easy. Wicked easy. Watch this. It's even less code than we had. JSON, open parentheses, hello to do. We're done. That's it. This is, don't trust me. Don't take my word for it. Go ahead and run that crap. And we get it again. Super powerful. Now, we have an ad break coming up in just a second. I won't cover anything more in the class until that is over. So don't worry. I'll just sit here and chat a little bit. I'll probably actually fix my tab completion while I'm in the ad break. So. So, yep. We have. Oh, sorry. Oh, okay. Cool. I really like this because, like, to me, it makes it very. My goal today was to show off how all of the compiler is trying to help you not have errors and not have bugs. I also love when projects take this approach where it's like, no, can we make sure that you're returning the right type? Don't just return a string. It's good. I like it. All right, let's fix. While the ad break is happening, let's do in Vim. No. What is it called when you accept a completion? Is it completion? I mean, I do like this is like one of the things that I dislike about Go. I like Go for a lot of reasons. One of the things that I dislike about Go is its completions. Or not its completion. I'm sorry. I read the word in front of me. Okay. I don't have it as tab here. Control Y. Is Control Y the right way to do this? I've always used tab. I'm just gonna. Is it just tab? I don't know if there's a special thing for this. I'm just gonna see if this works. I just did the base Kickstarter. Like, this is basically a brand new config. Struct. Okay, tab's working now. All right, we got it. Cool. I'll think on that one. Sorry, I don't think about how, like, I redid my system a little bit, and I didn't think about how it would affect, like, doing these learning things. And I'm like, oh man, I'm just, like, I don't want to sit here and talk about like I have to type this whole thing out because I have no idea how to accept the completion, and it's just a stupid completion. Okay. So did that ad break give everybody a little bit of time to catch up? Is everybody here? And, you know, I think the best way to do this is actually to be typing this stuff out. Also, does anybody have questions about this? I think that this is really important because understanding this helps you understand the power that Rust is trying to do. Like, this is the simplest thing I could come up with to demonstrate how, no, we're not just returning a string, and we're not just returning JSON. We are returning JSON of a to-do. And that is super powerful. That is super, super powerful. Yeah. Anyways, I hope that was like the best example I could find with that. And it was pretty cool because you got to see how to actually serialize it with Serde, but you got to kind of make the progression. Hopefully people liked it. Hopefully it makes sense. Let me know if it doesn't. All right. Now we still have a problem. We are just statically creating this object. That's not exactly what we want to do. What we'd like to do is to return a list that we can add to and remove from. So what we're going to do before we get to adding to this list, we're going to make the list in the main function with a to-do or two in this. And then we're going to read that list here. That's all. All right, that's all we're going to have time for. Then we got to get into the Kubernetes. And you know what? I forgot to update my title. Oops. Title's updated now. Okay, my bad. Okay. So let's go ahead and do this. Like I said, if you notice, all of these are asynchronous, and that's because Tokyo main is being called here, and we're awaiting on this, which means all of this is getting put onto an executor. That executor is going to execute these on, just the default here. It's going to spin up as many threads as you have cores. I think that's the default. If you don't give it any information, it's something like that. You can always go in here and check what the default stuff is, but I think the default doesn't matter. The fact is the default is multi-threaded. Okay, moving on. So that being said, these are going to happen on different threads. That means I can't just create something and expect to leverage it across these things without some form of protection. Now, Rust in its standard library has some pretty good mechanisms to do this. So we're going to import a couple things. There's actually just one thing that you really need, and that is use std sync arc. So arc. Okay, let's see. So an arc is an automatic reference count, which means that more than one thing can hold a thing. Now, this isn't specifically going to help if you want to add to it, but that's going to be something for next week. So basically, we're going to take this one step at a time. We're going to create an arc, which allows us to share multiple copies of the same. Oops, I just quit. That was my bad. Okay, going to allow us to share multiple copies. Let's leverage this. So we're wanting to create a list. So let's go ahead and create a list. So we're going to create the list here, and that is going to look something like let app state equal. Okay, so this is looking pretty good. We're going to create an arc. And that's going to be new. And inside the arc, we're going to initialize this. Now you could just give it a type, but we're actually going to initialize this with a vector because we want a list of to-dos. That's what we're going to do. So we're going to do vec like this and of to-do. So to-do, done. So this is how you create a list. This is a vector. This is a type of vector. And it's a macro that allows you to create a vector in the same line and actually fill it up. Basically, this would be a new empty vector. This would be a new empty vector, but we wanted one with a to-do. And so that's what we're doing. We're doing this app state. Now you can see we haven't used it and we haven't appended an underscore. So let's go ahead and use this. Why is Copilot working right now? Oh, you know what? I bet it automatically enables since I got out. Thank you. I thought that was just standard completion, but no, it's not. Thanks for calling. I got in and out because we fixed the tabs, and I think that turned it back on. Thanks for calling that out. Please always do, because, yeah. I was wondering why I hit tab and all of this filled in, because I thought it was just filling in like the to-do, but that wouldn't be auto-completion. Good call. Good call. Okay. So we have an arc now. But we need a way to share it. We can't just do app state. So any application like this is going to have their own way. Axum has their own way. And Axum's way of doing this is with this thing called use state. So when you're doing this here, and we're doing a little builder pattern here, we can put this down like this. We can do this. Use state, or no, it's with state. It's with state. With state. There we go. With state, and that state is our app state. Okay. Cool. Oh my goodness. Rust format put it in a line for me. We'll leave it. We'll leave it. We'll leave it. We're moving on. We're moving on. I made that pretty, and Rust format said no. All right. So how do we use that state here? Obviously, this function doesn't take anything. How do we access it? Well, obviously, they have a way to do this, and the way to do that is through this. You can do state. We're just going to call it to-dos. And that is going to be of a type of state, arc, vec, to do. 1, 2, 3. All right. That is the type. Now, there's actually some things that we can do to make this less painful to look at than this. And we'll do that in a little bit. But yeah, we'll make this a little bit better to look at in the near future. In the near future. All right. Now we have an error. The trait bound future output status code JSON is not satisfied. The following other types traits. Did I screw this up? I screwed this up. Let me look at this for just a second and understand, because I don't know where I went wrong exactly off the top of my head. But I did screw this up. This is solidly on me. Oh, you know what, Cypher? That's actually really good. Thank you so much for doing that. Everybody give a round of applause to Cypher. We should be doing that while we're doing this. For sure, especially when I screw up like this. Oh, I didn't import state. Okay. That's... I was like, why? Okay, but this is why we do this live learning, is because we learn to debug this. Now, in this one, it's not evident. It's complaining that this function doesn't meet the trait bound. So basically, what Git is looking for, Git this function here, what it's looking for isn't being met. And that was a little confusing, but sometimes you need to go to the next error. Sometimes the next error. Can't find the tuple struct or tuple variant state. Oh gosh, we forgot to import it. That's an easy fix. Easy fix. Okay. Do I remember? Is it just right here? No, it's not just right here. Where is it? Let me check in my notes. Do I have this? Oh, I do. All right. Now we're good. That was the mistake I made. And this is why sometimes people find Rust to be hard. Sometimes it's hard to figure out. I actually think the more you use the Rust compiler, the more evident it is what it's trying to tell you. But I think when you're first starting, it can be overwhelming. Okay. So does that mean we can get rid of this? Does it? Now, we don't have a hello to do, but we have this vector of to-dos. Okay, interesting. Can we just pass this state into here? So this would be to-dos. Can we just do this? Not exactly. And let's figure out why. So mismatched types, we expected a to-do, and we found an arc of vec of to-do. Interesting. Well, let's have this root state actually return all of our to-dos, because we now have a list instead of a single one. And, maybe in the future we'll change this to get all, or, we'll change this to something other than root. It's just the one we've been using. But let's change this to return a vec of to-dos. Can we do that? Okay. Now, this is saying maybe we need to use a conversion method. That seems a little weird, right? We have a vect. Well, the thing is, we have an arc. Actually. And so we kind of need to do something like, whoa. Now, what do we have here? Now, if you're ever getting confused as to like what you have here, so I know that you can go to the definition here, and this doesn't really tell you. You have a T or an A, or what do you have? Sometimes it can be confusing. So I always recommend when you're first getting started, do this. Let my to-dos. If you're getting confused as to what a type is, just make it explicit. Go to-dos dot as ref. Just go ahead and make it explicit. And now you can actually see however, oh, you know what? I can't because my command isn't working because we just changed. But you can actually see your thing should tell you what type this is. We're going to just open up Visual Studio Code because that's going to work for us. And I haven't made stupid mistakes. So let's go open a folder. I just want to show you that this is a great way of doing this. Not that you need to use Visual Studio Code. Don't save. Okay, so let's open up main here. Okay. Now you should be able to see what this is. This is a reference to a vec of to-dos. And if you notice, we don't really want that reference. That's not what we're returning here. We're not returning this in our code. Okay. We're not doing this. That's why it's looking for that. Now, there's multiple ways to fix this. But we can do, for just right now, 2vec here. We can just do a 2vec here. And we need clone. Oh, no. We don't have clone. It's not implemented for to-do. Now, you could hand implement clone, but we already have this amazing derive struct here that allows us to derive most things. And if you notice, we have a U64, a string, and a bool. There's no object inside of here that doesn't already implement clone. And because of that, all we have to do is type in clone in this derive, and we're done. All right, we can delete this line. And for kicks and giggles, let's actually make a second one of these. Just so that we just so that we see that we actually are doing what we're saying we're doing. Hello, my friend. Yes, it is true. Okay. And so let's run this. So now you can see that we actually get an array, a type-checked array of values. And this array is coming from a central shareable spot. Now we're going to go into mutating this, which is why you need the mutex in the next steps. I know I talked about it, which was a little premature. But next week we'll talk about a mutex, how we're actually going to share that state, how we're going to protect it, and how we're going to be able to edit it and make a post request to actually edit the to-do list. If we have the time, we're also going to add a database into it. We're going to use a project to create an SQLite database and leverage that locally. So like your changes will survive a restart. So yeah. How am I going to get into lifetimes? All right, so that is it for today. For this, we have a Kubernetes class starting off after this. Does anybody have any questions? Cypher, I'll talk about that in the halftime show. I'll talk about how we're going to do lifetimes. Xcoding, thanks for the follow. Is Drive doing code generation magic? Yes. So Cypher, that's kind of my point. I could have gotten into lifetimes here, but I'm trying to show people that you can actually do stuff. Maybe getting into lifetimes, you can make more performant code, but you can actually do stuff like, so my goal for the first class, the 101 class, is to never talk about lifetimes, other than in theory they exist, and sometimes we have to get around them. And my goal is to effectively prove you can make an application without writing explicit lifetimes. That's the first goal. Now, we're going to talk lightly about lifetimes and what they mean, like why you can't use the same thing over again if it's been consumed because of its lifetime. We're going to get into like the very basics of lifetimes. But the goal is to not have to. Now, what I'd like to do, probably next year, is do a deep dive where we get into proc macros, where we get into lifetimes, where we get into these more in-depth topics where there might be more theory than there is to these. Because like this is not meant to be theory and theory processing and a bunch of drawings. It's meant to be like, hey, can you get an application out that's, probably business ready. Probably business ready. I don't know. Oh, you were worried I was going, no. I have gone wrong if I get into lifetimes this year with this class. Or heavily into lifetimes. Yeah. What is my microphone and mixer? This is the RE20. I don't know if you know what microphones are. It's the RE20. My mixer is Linux. Is Drive doing something like code generation? Yes. So macros are kind of code generation, right? So this is going to generate some code. If you look at clone, now this clone is one that's a compiler built in. But if you look at like serialize or debug, these are your macros, and basically they take a token stream, and as they go through, they're going to build out the actual code. So kind of think like C++ macros, except they suck less. They're well typed from the get-go, like right here. They're well typed. They suck to write. That is why we're not going to write one. We're not going to write one until maybe next year, because they're hard to write, but they're really easy to use. They're really easy to use. All right, so the next thing is Kubernetes 101. Thanks, Cypher and Cat Muffin. Yeah, thanks for joining and your input. Let's open up Obsidian. All right. All right, let's just document really quickly what we did. So this would be the 30th of March, 30th of March. I missed that. 2024. I accidentally slammed day 2 into here, which is my bad. Let's do this correctly. What day 2 would have been last Saturday, so that would have been 7 days prior, right in between these two. That's a good math problem right off the top of my head. Never do math live on stream. There we go. Okay, so what is that would be 23, right? That would be the 23rd. 03 2024. And we're just gonna move day 2 into that. Done. Okay. Today was really about the type system, right? Learn type. I can't type. Type system is your friend. That was the basic idea of it. So for all of you just joining, I actually don't check this code in. And the reason I don't is I want to encourage you to write it, because one of the ways that Rust feels better is if you actually do it. And so my hope and goal is to encourage you to follow along, ask questions, and actually write the code, because that's going to be the best thing for you. So I know. We're gonna let's Vim it up here and really quickly just jump into main and copy this section out. I'm doing Vim bindings here. Okay. Let's see. I should have pasted it in here. Okay. That's easier. That's better. Let's do the good old, can we do Rust? There we go. Beautiful. Okay. Let's see. Started with, let's jump over into day 2. So if anything, I do check this in. This is checked in to Git, so you can find the notes. I'm trying to do a little bit better, to do well with keeping up on those. So hopefully, if you watched the video and had the notes, you'd be able to do that. You know what? I should have. Yeah, I'll show you what I should have done. Okay, that's basically what we did. My goal and my hope is to make a YouTube series out of this as well. You know, I'm doing it live because I love the live debugging. I love working through, you know, I love working through those types of things with everyone. But hopefully with these notes, we're going to make a YouTube series that just quickly and easily, like, they should be like 5 minutes each, steps people through it, and it should be a really good learning experience. So, all right, Kubernetes 101. We talked about what a Kubernetes container is. And today, we're going to have the pleasure of talking about what Kubernetes or what a container is to Kubernetes. And we're going to get our system set up to debug and play around with Kubernetes. We're going to actually create a container in Kubernetes. And we're also going to do that same container locally with Docker. And we're going to see some of the differences and similarities that exist. Okay. So we started with what is a container. And if you remember, we actually built our own Docker file for our day 2 release, which is now, day 3. If we're going to keep this up to date with the new name, we should just not name it based off of the day. That's pretty dumb. It's our to-do app. So yeah, we should name it something like to-dos. Okay. So we built our container here off of a base image called Rust. We copied in our code, we built the release, and then we said by default, we want to run the command to do. And this built an iron prison for our process. That's all it's doing, is it's building this iron process of bars that keeps the process from seeing other processes on the system. It keeps it from consuming too much memory or the whatnot. So that is what we did last time. We talked about containers, but what is Kubernetes? And I think people need to ask themselves this, because before you start learning how to use Kubernetes, which is what we're going to do, we need to understand what Kubernetes is. So let's start a new folder. So this would be 30 03 2020 24. All right. And then let's make a new drawing in here, and let's talk about what Kubernetes does. So we know that a container, this is a container. Let's make this. Isolates process on machine. So this is all it does. Isolates process on machine. This is file, network, process, you name it. It isolates on all of these levels. Not only does it isolate, but let's make this a list, because there are a couple of things. Container isolates. I'm gonna put this over here, up here. Yeah. File network process. Okay. One of the other things that it does via cgroups is limits resources that can be consumed. Okay. Again, disk, network, memory, etc. So it puts limits on how much that process can use. Okay. So these are kind of the basic things that a container does. What does this mean to Kubernetes? What is Kubernetes' goal? I know that a lot of times people explain Kubernetes as a thing to orchestrate VMs or things like that. We already talked about how different containers are to VMs last week. So what I'd like to do is talk about Kubernetes' true goal, which I think people don't understand. Kubernetes' true goal it is not to manage infrastructure. I know that that's going to blow people's mind. Let's actually put this: not to manage infrastructure. It is not a thing to, so Kubernetes doesn't manage secrets. It is not. Is it a database? Don't bring the database argument up right now. Don't do it. Don't do it. I will destroy you guys in what a database is. So it's not there to manage infrastructure. It's not there to manage your secrets. It is not here to solve any of those types of problems. And there's a lot of problems that people will bring up that it supposedly solves. Let's say it's not here to make DevOps possible. That's not one of its goals. Its goal is not, because you'll see that. And there's a lot of reasons DevOps teams and those like using it. I'm not saying it can't be leveraged in those scenarios. It absolutely can be leveraged in that. But this is not its goal. It's not what it's designed to do and why you would want to use it. If you say that you want to use Kubernetes because of DevOps, that's not the reason. It's not it's not any of these things. So let's get into what it is. What did I just press? Can we? Somehow I swipped. I don't know. I thought I had lost all of that. All right. So let's get into what it is, because this is going to blow your mind, because it's a lot simpler than what you might think it is. What is it? It is process orchestration. It is process orchestration. Now, it does a lot of things to support this process orchestration, but this is the root of what it does. Now, it does other things to support this, but this is its goal. If you wanted to look at its root goal, is process orchestration. And again, it does a lot of things to support this, but if you're asking yourself, do I need Kubernetes? You should ask yourself, do I need something to orchestrate processes better than I do now? Now, we know that Kubernetes leverages containers. What is a container? A container is an isolated process. It is a sandbox around a process. So if you think that Kubernetes is a container orchestrator, this all starts to make sense. Containers are the framework in which it orchestrates processes, and containers make orchestrating processes a little bit simpler in the context of Kubernetes, because it gives this well-defined set of tools and resources and things like that. So this is what Kubernetes is. Any questions? Sorry. I get really excited about this because I feel like so many people look at it in the wrong way, because they'll be like, oh, we use it to manage. You can manage infrastructure with it. You can manage secrets with it. You can do amazing DevOps things with it. All of these things are possible leveraging it. But its goal isn't to do these things. And if you need it or not, you shouldn't be asking yourself about these types of things. What you do need to ask yourself is, do you need better process orchestration? And if the answer is yes, then let's dive in. This is the class for you. I know, I got a little didactic. I apologize. I just get excited about this. Okay, so we have containers, which is a sandbox around this. Now, technically, Kubernetes doesn't actually orchestrate containers. They orchestrate pods. Pods. What the crap is a pod? Why do we need it? Well, the answer is we don't actually need it, but we have it, so you're going to have to learn it. A pod, a group of containers. That's it. A pod is a group of containers. I want to show this to you, demo it to you as a real world example. Let's get rid of this. Let's do K9S. And let me show you a pod. See these numbers here? This is the number of containers running. A pod is a collection of containers that work together. So this has 2 containers in it. This is an init. Don't worry about the init container. This one technically has 3 containers in it. This one runs once. These 2 run side by side, and these actually communicate together on localhost. What happened? Well, actually, they're sharing file, but it doesn't matter. What happens is that this is saving. So when there's a new Twitch alert, when there's a new follower, when there's a new subscriber, whenever there's a new Twitch alert, this saves it to a local database. This then replicates that database into the cloud to save it in case something happens to local copy. So these 2 things work in tandem, but they're 2 isolated processes. This is what a pod is. When they talk about a pod, it's just a group of containers, 1 or more. A lot of the times you want to keep it as 1. I only bring this up is because too often people start to think of a pod as a container because they're so accustomed to that one-to-one relationship, but it can be a group of containers. Just keep that in mind. That's what a pod is. And this is what Kubernetes orchestrates. So let's go ahead and install Kubernetes locally. Now I'm going to point you to this. Kubernetes kind. This is what I'm going to ask you to install. There are other ones, and if you want to install them, that's fine. But if you're wanting to do this alongside of me, I'd like you to install, and this is an easy one that you can install just with Go. You can run this Go install kind, and then leverage kind. So it doesn't matter what your package manager is. If you have Go, you can just install kind with this. So you can just install it with Go install kind. Run that. It's going to take seconds. I was going to say a minute. Seconds. Now, what does kind do? It allows you to run a local Kubernetes cluster. If you actually look here, we're going to start leveraging a thing called kubectl, and it's going to be fun, and then it's going to be terrible. You'll have fun with it at first, but kubectl is the main way to interact with Kubernetes. This thing. Now, you'll see that my setup currently will tell me about the Kubernetes cluster that I'm connected to and whatnot. But there's a way to config this. Let's do this. kubectl config, and then we'll want to use context, and then we'll do kind. Now, this kind cluster is the one that's created default by kind. Let's go ahead and delete it and create a new one, because this is one that has just been running on my machine. So kind, delete, cluster. Now, we can actually name these clusters, and we're going to do that because you're going to run 2 clusters on your machine just to get some experience with it in the future. All right. So now if we do kubectl, you can see that I don't have anything here because I'm not actually configured to hit a valid Kubernetes cluster. So let's fix this. Let's create a cluster. This is the amazing thing. On your first run, kind is going to take a little while because it has to download, but watch this. Kind create cluster. I'm pulling new images. I think I was on 128, so I'm going to take a little while too, but a little while is not very long. Elevator music. Too soon for elevator music. We didn't even have to wait as much time as it would take for an elevator. All right. So now, if we run kubectl, we have a Kubernetes cluster locally. If you guys don't have kubectl installed, install it through your package manager. Almost every single package manager has it that I know of. I know Debian does. I know Ubuntu has it. Here's a link to this. There's a Mac OS and Windows. I should have started with this. I forgot about the command line tool. Install kubectl. Install it. Oh boy, install it with a binary on. Oh gosh. I know the package managers have it. So here's Debian, Red Hat, and SUSE. I know that Arch has it because Arch has everything. Yeah, just go install it. Easy peasy. Easy peasy. Once you have it, does everybody have a Kind cluster set up and kubectl? The other thing that you can do if you're looking for alternatives to Kind is the easiest one because it doesn't mess with your system or anything. If you're on Ubuntu, there's microK8s. What is it? What microK8s? Yeah. There's microK8s if you're on Ubuntu. So you can use this. I think microK8s works on anything that is Snap. So if you have Snap installed, you can use microK8s. There's Minikube. And there's Minikube. There are pros and cons to both Kind and Minikube. I think Minikube is much more powerful. And if you're trying to do very unique, very special things and wanting to do like VMs and stuff, you can do that with Minikube, whereas you can't with Kind. But Kind is faster and easier in the majority of contexts. But we're not getting into that. My goal was just to get into doing some stuff. Okay, so we have a Kubernetes cluster. How do we interact with it? Well, we use kubectl. This is the command line tool for it. Now, a lot of people, because you type this a lot, use the word K to do the same thing. You can see that's the same command here. You can see when I type command, because I aliased it. It's pretty common. All right. So we can just type K now. Another really great one that you can go download is K9s. You'll see me use it every once in a while. You can see there's nothing running in our Kubernetes cluster, but it gives us a bunch of different things. We can actually go and look around. This is our default namespace. Okay, but let's get out of that. It doesn't matter. All right, so we have this new cluster that we created. It's called Kind. We want to do something in it, right? Well, you need to run a container. That's everything in Kind, or everything in Kubernetes is based off of these pods and creating pods. And to create one for Kubernetes, you need to have a container that you want to run. So let's run a container. Now, you'll notice that Kubernetes doesn't have a concept of a container. So if you do K create container, it's going to say the container is not known. It doesn't know what a container is. And this is why I talked about pods. And I made this distinction clear that a pod is a group of containers because, well, if you don't realize that, then you'll be like, why do I not create a container? Well, you don't create a container because Kubernetes only cares about pods or collection. You could think of it as a list of containers, honestly. Yeah, let's think of it as a list of containers. Yeah, anyways, so we can do k create pod. And you'll see that we have to specify one of F or K. Okay. Interesting. What if, see here? Check this out. These are available commands. Wait, is pod not one of these? I thought pod was one of these. Holy crap, pod isn't one of these. You can make a deployment, but not a pod? I didn't realize that. Is that what? Okay, well, I just learned something new. Can't create a pod YAML spec from this. So let's go ahead and create one. A lot of the times what you'll see is these YAML definitions. And I was going to actually create it with this one. But I guess pod isn't a part of create anymore. Is that true? Yeah, I guess it's not. Was it never? Maybe it was never. It doesn't matter. We're gonna do it anyway, the hard way anyways. So we're gonna vim and create pod.yaml. So this is gonna be our it's not a deployment. Deployment's actually another thing that we're gonna get into. We just want to run a pod. And the easiest thing to run is like Nginx. So let's just do that. Now, there's a couple things that you need at the top. You need an API version. And this is just going to be v1 for the pod spec. And the kind is a pod. Oh my gosh. 1 second, Copilot's doing it to me. Copilot disable. Sorry, we don't do Copilot on lessons. Okay. So the kind is going to be a pod. There's this thing called metadata. And in here, we're going to give it a name. We're going to do Nginx. This can be anything. We'll call it Wilbur. Just to prove that it can be anything. It can be anything. That's the name. I mean, you probably want it to be specific. And then this spec is the actual pod spec. We're defining the spec here. And you'll notice that in the pod spec for a container, you have exactly the thing called containers. Because you have a list of containers. That's the idea behind it. This is a list of containers. So we'll start it with a list. We'll name this one. This one's going to be called Nginx because that's what we're doing. We're getting Nginx. The image. So this is the container image. Now, a lot of people will go to Docker Hub, and we'll jump on here. We'll search for it. You can search for a bunch of images or create your own like we did last time. We'll look for Nginx. Does Nginx have a good container? And the fact is, yes, it does. Here's an Nginx container. So you can see it's just Nginx because it's one of the officially built containers. So the image is just Nginx. We'll get into using our own image in a bit. And then we can just do this. Now, this is not exposing any ports or anything, and we'll get into that more. But let's see if this works. Let's see if Wilbur works. Will Wilbur work? Is the question. So how do we get this to our Kubernetes cluster? Well, we get this by applying it. So you can do k apply-f pod.yaml. So the F is for file. There's a K for customize. Don't worry about customize. We'll get into customize a little bit later. But this is going to apply it to our Kubernetes cluster, and it's our kind Kubernetes cluster. So let's go ahead and apply that. And you'll see the pod Wilbur is invalid. Okay, so there is some checks that are being done, and we uppercase that thing. And it needs to not be uppercase. Okay, fair. I actually don't even know why I put it in here. Wilbur. Terrible name. My point is, it doesn't have to be Nginx. All right. Awesome. We created it. Kubernetes said pod Wilbur is created. Now, you realize we only created a single process, but let's check on it. Can we check on the status of our pod? Okay, get pods. All right. There we go. We have it. We're using kubectl. This is kubectl. Get pods. What else can we do? We can do O-wide. O stands for output. This lets you define how you want the output. Wide is just a little bit more information, but it's still in a pretty chart to read. Are there other ways? Yeah, let's do O YAML. So now we want the output of YAML. This is going to give us everything. This is the entire state of our pod. Our pod Wilbur. This is really easy because you can do stuff like grep in here for image, and you can see what image it has, what image pool policy has, and we're going to get into these other things here of exactly what these things mean. But you can see that we have the image of Nginx. Awesome. So if you were looking for that, you can see that. And if you do the O-wide, one of the cool things here that you can see is you can see what node it's running on. Now, right now we're running a single node Kubernetes cluster, but we're going to run multiple nodes because Kind actually lets us run multiple nodes locally. And we're going to see what I mean about Kubernetes orchestrates processes. That's what it's designed to do, is orchestrate these processes in a well-defined, controllable way. And that's really its goal. And so right now you can see what node this is running on. Any questions so far? I know that I skirted over a bunch of stuff, but there's just a bunch of stuff here. And I just want to get our hands dirty and start experimenting with stuff. Oh, there's an ad in progress. Fantastic. Good time to stop. Pause. Thirty more seconds. $25 more seconds. Okay, so I just don't want to do class stuff, educational stuff. All right, everyone back? All right, I think everybody's back. Cool beans. Alrighty, what were we talking about? Okay, we were talking about this is our pod. This is running. It's a container running in our Kubernetes cluster, which is actually pretty cool. If we do Docker PS, this is checking our local one. You'll notice that Docker actually has this kind node. So how kind works is it actually runs a container that is Kubernetes, which is very interesting. So if we wanted to actually see what was running on this node, we'd actually have to jump into this, which we can actually do. We can actually do this. So again, I don't know where everybody's starting from. So I'm starting from very simple with like Docker commands and things like that. But we'll get into more complicated commands as we go. So let's actually exec into a container. Let's figure out how to do that. There's a Docker exec, a Docker exec command. We're gonna pass it IT, and then we're gonna pass it the container ID, just like this. Pretty simple. And we need to pass it an argument to actually run. So it works better if you actually run a command in it. So let's just run. Let's see if it has bash in it. It does. It does. Cool. So this container has bash. We're running bash on the kind control plane. This node, kind control plane. When you saw that it was, now we're on the node that is our Kubernetes cluster. Does it have Docker? I don't think it has Docker. So this is one thing that we're gonna have to play around with. I'm probably I have a bare metal cluster that we're gonna actually experiment with and show on a little bit because it's easier to exec into and see some of this stuff where I can have Docker installed on it. But we're now on this, and it has the containers running on it. So this is pretty cool. Can we Docker? You know how we Docker exec here with a container? Can you do that same thing with Kubernetes? The answer is yes, you can. Yes, you can. Let's do it. So get pods is going to list our pods here. We have a pod Wilbur. Can we Kubernetes exec into that? Well, let's give it a try. Let's give it a try. So let's see. This is kubectl. Oops, CTL. There we go. So it's still the exact same exec that you would do, and I think we can do IT. We'll see. The one thing you have to do differently is you have to do the double dash here, and then bin. We'll just do sh. Didn't find sh. Not bin sh. Bash. Wait. Pod. Oh, we didn't tell it where we wanted to, what one that we want. We want to go to Wilbur. Okay. There we go. We're now exec into our container that we're running. We didn't actually need to know which node it was on. We're exec into Wilbur running Nginx. Now, sometimes containers won't have bash, so there's other things that we can do with sidecar containers and things else. But the ones we're going to use for right now will have bash installed, which is pretty cool because it allows us to see into the container and we can exec into it just like this. And we can get out of the container just like we did with Docker. So a lot of the things that you could do with Docker, if you've learned Docker and the Docker CLI, you can also do with Kubernetes and the Kubernetes CLI. If we're talking about K9s, you can actually do the same things here as well. So here we have Wilbur, which is nice. We can look at Wilbur. We can actually get the logs from Wilbur. Ooh, let's do that with the command line too. The other thing that you can do is you can attach to it. We can do attach, and now we're attached to Wilbur ourselves. Pretty cool. Pretty cool. So K9S is pretty nice and straightforward. It's pretty easy and simple to use. I have been liking it. I've been liking it. All right. So what we're going to do is next week, this is a pod. This is a process. It's running. It's there. But right now, there's no way to actually hit this. We can't curl. There's no way to curl it. It doesn't have an IP address that's usable to us. And so we need to fix that. So next week, what we're going to do is we're going to do a very, very basic service to access the process. And what I want to tie all this together into is that everything that Kubernetes gives out, whether that's the load balancers or the services in general, like the node port service, it is to support process orchestration. All of these things are there to support process orchestration. And I think that helps clear it up. Because what happens is when Kubernetes runs, its goal is to orchestrate your process on a bunch of machines. And if you don't know where that process is, how do you get traffic to it? That process could be here, and it could be here. Maybe it's in both. Maybe you're running two of them. How do you get traffic to the processes that you want to have traffic? Thinking of Nginx, it's an HTTP server. So we want to get HTTP traffic to that server. So that's what we're going to cover next week as we look into, what Kubernetes does in a very practical walkthrough. I'd go ahead and explore Kind. I gave you the link to Kind. Kind is going to let you experiment locally, and we're going to leverage that. And just start typing some stuff. Make a Kubernetes pod. Make a pod. We're going to actually leverage a deployment, and we're going to talk about what the difference between a deployment and a pod is. Watch this. K get pods, and we're going to do K delete pod Wilbur. K get pods, and you'll notice Wilbur's deleted now. This is cool, but we can actually make it, and I'm sure that you've seen it, where Wilbur comes back. Wilbur comes back. You can make that happen. And again, this is about orchestrating your process. It's very cool. Very cool. I'm trying to do this like the most simple way while covering some of the theory so that people aren't confused. I don't know. How are you guys liking it? How's the Kubernetes? I don't know. I was going to start without any of the other stuff, and we're just going to start with the deployment. But then I found out that there was several of you that didn't know anything about Kubernetes or even containers. So I thought that we would cover some more basics. So we are starting pretty basic. But yeah, hopefully it's making sense. You guys are a little quiet, which is making me worried. Quiet is either heads down or it's confused. All right, we have Wilbur back. You know what? Let's exec back into it. I just want to prove that this is like our running container. Now, you guys might... One thing that I made the point that this was just a process. And you're going to look at this and you're going to say, this looks like a virtual machine. And I guarantee you that it's not. What happens is that when you build a container, especially one like this, it requires a lot of different things. So we could look in the SBin here. It requires a bunch of dependencies. And hopefully, if they've done it right, these are just the dependencies that they need. Now, what you'll find out is a lot of these containers are actually bloated, and these are more dependencies than it actually needs. Nginx probably doesn't need all of these. dependencies. And they should be removed, to be fair. But that's also a lot of work. So, yeah. It should be bundling just the things that it needs. There won't be a kernel in here. It probably has more stuff than it needs to, but that's just because of the container ecosystem. A lot of containers that I build don't have bash in them. So you can't actually do this because they don't have bash or sh or any of those. Think about the number of dependencies bash has. It's quite a few. Quite a few. All right. Let's see, what time is it? Do we have... No, I don't have time. I ain't got time. Let's find somebody to raid. Let's find somebody to raid. Do you guys want to... We're going to raid Rob. Rob does a lot of educational stuff. He does some biking too. We're going to raid Rob. Tell him I said hi. And maybe learn something new from him. All right. Thank you, everybody, for joining me. I hope that this was helpful. And give me feedback on the Kubernetes. It's such a big area. There's a lot to cover. I'm just trying to jump into it and do some stuff. So in that case, I'll see you guys next week or throughout the week. Have a fantastic week.